All right, my JEE aspirants. Hope you're revising. Hope you started studying preparation for 2026 January shift. Those are preparing JEE exams for JEE exams. This time I'll be doing 2025 JEE Main limits PYQs. Okay, both January and April shift will be covering. So far we have done 2019, 2020, 2021, 22. 2023, 2024, all the PYQs of limits chapter we have covered. This time I'll be doing 2025 JEE Main limits. After this, I'll be covering all the 2025 appeared questions of different topics. Okay, and those are new to our channel. Just an explain about our Abhiram's Maths Marathon classes. This is my Abhiram's Maths Marathon classes started recently, just 1.5 months back. And I've done a few videos. I'll be uploading more and more videos. We have target of uploading more than 1,000 videos in this entire year. Not only JEE Mains, also I'll be doing NCERT syllabus, okay, CET, exam book, synopsis of each and every chapter will be covered with examples in detail for both JEE exams as well as KCT and any other competitive exams. I'll be covering the synopsis part. The synopsis has to be very strong. You should have a powerful synopsis. Then only you can crack the questions in lesser time for competitive exams. Okay. Even in JEE exams also, after 25 questions, minimum 5 to 6 questions will be there. You can crack within 15 to 20 seconds. There will be some questions, but your synopsis part has to be very strong. It should be very powerful synopsis. Such a synopsis you should know, and only those formulas which you can remember you have to learn. Okay, you can't learn everything and keep it in your mind, because what you study in 2 years, entire 2 years, is writing the exam in 3 hours, right? So that only 1 hour for maths. And those who want to attend more number of questions, want to get more right answers in JEE exams, you should practice a lot, and you should have a proper planning also. Mathematics, you need 80 minutes. 60 minutes is not enough, I can tell you. Many students have told me about this. You need to keep 80 minutes for mathematics to complete the paper. I'm telling about JEE exams. Okay, you have to finish physics and chemistry in lesser time. You can't keep 2 hours for finishing physics and chemistry exams. Okay, so you have to transfer the physics and chemistry time to mathematics so that you can complete the paper. Okay, because many of the questions in JEE exams will be moderate level. It won't be so easy, it won't be so difficult also. Moderate level questions, but lengthy questions will be asked. Time consuming questions. Your calculation part has to be very fast. You have to be, the problems will be calculative only, so the calculation part you have to do it extremely fast, and the formulas you should know all the formulas. It should be at the tip of your tongue. There is no time for thinking. Okay, so far I've done a few videos connected to my channel Abhiram's Maths Marathon, and these are the various JEE Main questions I've covered. Chapter wise I'm covering all the previous year questions. So for example, I'll explain to you in this limits. Here I'll show you that there is video solution is available. Video solution is available for each and every chapter. If you go to the description box or the comment section also, you can see this video solutions. PDF, the solutions are available in the PDF format, and for each and every question there is a video solution. Video solution is available. See, this is the first question of 2024 shift. 1st February, first shift, okay, 2024. The question is there, and also the detailed solution is there. Okay, detailed solution. Look at the solution. So in detail I have given the solution, and if you want to view the solution, the video solution, you can press like this and you'll get the video solution for this question. Okay, likewise all the shifts we have completed, 2019, 20, 21, all these things. Okay, 19, 20, 21, 22, 23, 24. Question by question, the PDF format is also available, and also the video solution for each and every question is available. Okay, you can go to the description box, you can see it. Okay, so this is what we have. Okay, in the comment section also it is there, and also it is there in the description box. You can just view it. Okay, so this is about my Abhiram's Maths Marathon classes. So we'll start now. JEE Main 2025 question one by one. The first one, limit x tends to infinity e by 1 minus e into 1 by e minus x by 1 plus x whole to the power x equal to alpha. Find the value of log alpha by 1 plus log alpha. Various options are given. Question asked on 22nd of January, second shift, 2025. Okay. So first we'll simplify this. There are various indeterminate forms. So 0 by 0, infinity by infinity, 1 to the power infinity, infinity minus infinity, 0 into infinity, 1 infinity power 0, 0 power 0. Various indeterminate forms are there. 7 indeterminate forms. We shall see which of the indeterminate form it takes first. Then we can evaluate by the known methods. Correct? First we'll simplify this bracket. Okay, e by 1 minus e multiplied by 1 by e minus x by 1 plus x is given. So simplify this bracket. The power is anyway x, no? The power is becoming infinity. Most probably I can give guarantee that the given question takes 1 to the power infinity form. For that we shall simplify this bracket. Okay, e by 1 minus e is there. E by 1 minus e. The first bracket is e by 1 minus e, correct? Here I shall take LCM. This is the first bracket, is multiplied by. Second bracket I shall take LCM. E into 1 plus x, e into 1 plus x, correct? Numerator becomes 1 into 1 plus x, 1 plus x minus xe, correct? After taking common denominator. This e is going to cancel. E is going to cancel. So what is left is 1 plus x minus xc, or else I can write 1 plus x into 1 minus e divided by 1 plus x into 1 minus e. I'm getting like this. Correct? The bracket is simplified. I'm getting like this. See, look at the numerator and denominator. Numerator, the highest power of x is 1, right? Even the denominator is the highest power of x is 1. 1 plus x into 1 minus e. So degree of numerator and denominator is same. Both numerator and denominator are polynomial functions. They are of degree 1. Degree means highest power of x. So it's a polynomial of degree 1. So limit x tends to infinity is there. So it is the limiting value is the ratio of the leading coefficients. Correct? So leading coefficient is the coefficient of the highest power of x. That is what I'm telling. So if you apply limit for this, I'm going to get the answer as 1. Correct? Because as x tends to infinity, if degree of numerator is equal to degree of denominator, then the limiting value is going to be the ratio of the leading coefficient. Means coefficient of highest power of x in the numerator divided by coefficient of highest power of x in the denominator. Correct? So coefficient of x is 1 minus e here. In the denominator also, coefficient of x is 1 minus e. This will tend to 1 as x tends to infinity. Correct? As x is approaches to infinity, I can tell this base is approaching 1 and the power is approaching infinity. So it is typically taking 1 to the power infinity form, a typical JEE question. Correct? Many times the questions are asked based on 1 to the power infinity. Even in 2025, one such question we can find. So 1 to the power infinity form. It's a typical JEE level question. So whenever it takes 1 to the power infinity form, we have the formula. Limit x tends to a, f of x power g of x is equal to e power limit x tends to a, g of x into f of x minus 1. If you want to write the formula here. What is the formula? Already I've done the synopsis part of limits in detail. Again I'm writing the formula. Limit x tends to infinity or limit x tends to a, f of x to the power g of x. If it is like this. If the base is approaching 1 and the power is approaching infinity, in that case we apply this formula, not otherwise. The base should approach 1 and the power should approach infinity as x is approaching a. In that case we have the formula e power limit x tends to a, g of x into f of x minus 1. Learn this formula, very important. It's a level 1 kind of question. It's not a level 2 for JEE. It's a very standard type of question. Many times we can find this kind of question in many of the shifts. 1 to the power infinity is such a familiar question. It's a typical JEE level question. Level 1 kind of question I can give. So I'll apply this formula 1 to the power infinity as x approaches to infinity takes 1 to the power infinity form here. So e power limit g of x into f of x minus 1. So to evaluate that, I shall write here that limiting value is going to be, that is alpha is equal to e to the power limit x tends to infinity. Write the power first. The power is x into the base minus 1. Base has been simplified, no? I simplified these two brackets. I multiplied those. I simplified this by taking a common denominator and I got like this. I'll write this one now, okay, instead of writing that. So 1 plus x into 1 minus e, 1 plus x into 1 minus e divided by 1 plus x into 1 minus e is there, the base minus 1. The base minus 1. So what do you get? This is equal to e to the power limit x tends to infinity, simplify this bracket, x multiplied by taking common denominator 1 plus x into 1 minus e, correct? Taking common denominator 1 plus x into 1 minus e. Here what I'll get? 1 plus, I'll multiply x into 1x minus xe minus of, this will come to numerator, correct? 1 plus x into 1 minus e. Simplify this, that is alpha value. Further to find log alpha by 1 plus log alpha, correct? So this is equal to e power limit x tends to infinity. What we have? X into, here open the bracket, denominator also you can simplify if you want. This will be numerator is what? 1 plus x minus xe minus 1 into 1 minus 1 minus x into 1 minus x minus 1 into minus e becomes plus e minus into minus plus xe, correct? Some terms might cancel here, correct? Plus x minus x will cancel, minus xe plus e cancels, means sum will become 0, even plus 1 minus 1 will add up to 0. What is left there is e, correct? In the denominator I can multiply if you want, otherwise keep as it is, multiplication is not required there. 1 plus x into 1 minus e is there. So what we have? E power limit x tends to infinity, here x into e, correct? X into e divided by 1 plus x into 1 minus e. So here also the power what we have here, xe by 1 plus x into 1 minus e, it is degree of numerator and denominator is same, correct? Both are polynomial of degree 1. That means limiting value is going to be the ratio of the leading coefficient. Means limiting value is coefficient of x in the numerator by coefficient of x in the denominator, correct? See, you can see the power of x is 1 here. Here also the power of x is 1, correct? When you multiply, the limiting value is going to be the coefficient of x in the numerator by coefficient of x in the denominator. So this will simplify to what? E power, the coefficient of x in the numerator is e, and coefficient of x in the denominator after multiplying it 1 minus e, that is equal to alpha, correct? That is equal to alpha. That's what I wrote here. Alpha is already written here. So alpha is e power e by 1 minus e. What you need to find is log alpha by 1 plus log alpha. So I can write the remaining part here. Log alpha by 1 plus log alpha. No. Therefore, if you take log on both sides, because alpha is e power e by 1 minus e, log alpha is equal to how much? Taking log on both sides, log e power e by 1 minus e becomes e power 1 minus e by 1 minus e comes down, correct, into log e becomes, correct? The power comes down using log on both sides. Take log on both sides, log alpha equal to log of e power e by 1 minus e. The power comes down. You know the property of log m power n is n log m, correct? The power comes down using the property of log, correct? So, and log e is 1. Log e means log e to the base e is equal to 1, correct? This becomes 1. This is equal to 1. So we get e by 1 minus e. The value of log alpha is e by 1 minus e. What we need to find is log alpha by 1 plus log alpha. So log alpha by 1 plus log alpha. Look at this. I'm substituting for log alpha. And I got log alpha as e by 1 minus e. So I'm write e by 1 minus e divided by 1 plus e by 1 minus e. So that is equal to e by 1 minus e, numerator keep as it is, denominator take LCM, 1 minus e, correct? 1 into 1 minus e becomes 1 minus e plus e. So 1 minus e cancels, minus e plus e will add up to 0, e by 1, e is answer. Option A is answer. Correct? Solution is also given to here in detail. Solution is given. If you want, you can take the screenshot, or else I'll send the PDF also. Question by question, the solutions will be sent in the PDF format. Also, the video solution is available for each and every question. So, answer is E. Alpha we got, then find log alpha by 1 plus log alpha. Question asked. 1 to the power infinity form. Move on to the next one. Second question. Limit x tends to infinity. We have 2x squared minus 3x plus 5 into 3x minus 1 power x by 2. divided by 3x square plus 5x plus 4 into root of 3x plus 2 power x. Various options are given. Question asked on 23rd of January, second shift, 2025. Here, numerator, first bracket is a polynomial of degree 2. In the denominator, the first bracket is a polynomial of degree 2. We can apply limit of the product equal to product of limits. Limit of f into g is what? Limit of f into limit of g. I shall separate out this, okay? Because for this I can apply limit separately. As x tends to infinity, degree of numerator and denominator is same, means limiting value is the ratio of the leading coefficient. I can use that concept. So I'll split this product. Limit of the product is product of the limits. So limit of f into g is limit of f into limit of g, using that concept. I'll treat this as the first function f, okay? And this is a rational function, correct? Numerator is polynomial and degree, and denominator is also polynomial. Such a function we call it as rational function, correct? I'll separate out this rational function, and here there is power x by 2 is there. That will separate out. Okay, and square root means to the power half, right? So even this, 3x plus 2 power x will be raised to the power half, means the power becomes x by 2 for both of them. So I'll separate this. This is equal to limit x tends to infinity. Limit x tends to infinity. I'll write 2x square minus 3x plus 5 divided by 3x square plus 5x plus 4. Treating this as a first function, this rational function is taken as f, and this remaining part is taken as second function. That is limit x tends to infinity, limit x tends to infinity, 3x minus 1 to the power x by 2 divided by 3x plus 2 to the power x by 2. 3x plus 2 power x whole power half. Whole power half. The powers gets multiplied, correct? 3x plus 2 power x power half. That is 3x plus 2 to the power x by 2. Like this I can write. Applying limit of the product as product of the limits. So now I can evaluate this separately, correct? This is a one line answer for this. Because the degree of numerator equal to degree of denominator. You can see degree means what? Highest power of x. The highest power of x is 2 here. Highest power of x in denominator is 2, correct? Both have same degree, x square. So limiting value is what? As x tends to infinity, coefficient of x square is the numerator by coefficient of x square in the denominator. So limiting value for this is going to be equal to 2 by 3. Okay, I've given the examples also how to evaluate such kind. Even this kind of question can be asked for CET exam, only this part, okay? I'm telling. Now, to evaluate this, see in the numerator and denominator, both the powers are x by 2, correct? So I can write it as limit x tends to infinity, 3x minus 1 divided by 3x plus 2 whole to the power of x by 2, correct? Both degree of, both the numerator and denominator both have the same power. So I can write like this. A power x by b power x, a by b whole power x. So now, if we concentrate on the base is a rational function, degree of numerator is 1, degree of denominator also 1, so degree is same, means limiting value is coefficient of x in the numerator by coefficient of x in the denominator. Coefficient of x is 3, coefficient of x is 3, limiting value is 3 by 3, limiting value is 3 by 3, which is 1. So the base is approaching 1 and the power is approaching infinity. This takes 1 to the power infinity form, correct? Our usual 1 to the power infinity form. This part I am telling. This part is approaching 1 to the power infinity form. Again apply our formula. Whenever it takes 1 to the power infinity, we have the formula limit x tends to a f of x power g of x equal to e power limit x tends to a g of x into f of x minus 1. I'll apply that formula. So that's equal to what? 2 by 3 into e power limit x tends to infinity g of x, means the power you write first, power into base minus 1, power into base minus 1. Simplify this. 2 by 3 into e power limit x tends to infinity, what we have, x by 2 into, take LCM inside the bracket, 3x plus 2, correct? 3x minus 1 by 1, 3x minus 1 minus of 3x plus 2. That's equal to 2 by 3 into e power limit x tends to infinity x by 2 into, here 3x will cancel, minus 1 minus 2 becomes minus 3, correct, open the bracket, divided by 3x plus 2, like this I'm getting, correct. So further simplified, what we get now to evaluate this, now once again it is taking degree of numerator equal to degree of denominator. So limiting value is ratio of the leading coefficient of x in the numerator by coefficient of x in the denominator. This will be equal to 2 by 3 into e power, see coefficient of x in the numerator is minus 3, coefficient of x in the denominator is 3 into 2, 6. So limiting value is coefficient of x in the numerator by coefficient of x in the denominator. So what do you get? Minus 3 divided by 3 into 2, 6. That is 2 by 3 into e power minus half. E power minus half is 1 by e power half. So 1 by root e I can write. So answer is 2 by 3 root e. Correct? 2 by 3 root e. E power minus half is 1 by e power half. E power minus half is nothing but 1 by e power half. That is equal to 1 by root e. Correct? Power half means it is root. So answer is option D. Separating this, limit of f into g is limit of f into limit of g. Limit of the product is product of the limits. Apply limit for this. Apply limit for this separately. This is directly because degree of numerator and denominator is same. Limiting value is the coefficient of x square in the numerator by coefficient of x square in the denominator. I have not done the actual method. I am just applying the shortcut. If you want, you can do the actual method also by taking the x square term common. Even though it's not common, forcibly you can take out x square and balance it by dividing by x square for the term and use the concept that as x approaches infinity, 1 by x will tend to 0. Even 1 by x square will tend to 0. Such concept if you apply, you'll get the answer as 2 by 3 itself. You can try if you want, taking x square common out. If you want, I'll show the step here. See, take x square common there. X square common, what do you get? 2 minus 3x divided by x square plus 5 by x square. Those who don't know how it has come, directly I wrote the answer by using the shortcut method. If you want to understand, I'm just doing this separately. X square into, correct, take x square common. Even though it's not common, I'm taking it out. Okay, even though it's not common, it's taken out and balance it by dividing by x square for the term. So x square is taken out means what remains? 3 plus 5x by x square, correct, plus 4 by x square. So that it is balanced. X square cancels. Limit x tends to infinity is there, no? When you apply limit, no, 3 by 1x will cancel here. 3 by infinity is 0. 5 by infinity is 0. As x tends to infinity, even x square has approached to infinity only. This will become 0, this will become 0. 2 by 3 is answer. 2 minus 0 plus 0 is 2. Numerator 2. Denominator 3 plus 0 plus 0. 3. 2 by 3 limiting value. Those are not known the actual method, just shown it here. X tends to infinity is there. That is the actual method, but directly you can write for competitive exams. Okay, this is 1 to the power infinity form, and the solution is also given here. Answer is option D, 2 by 3 root e. Detailed solution is given to you. Next one, question number 3. A function f is defined from all real numbers except 0 to real numbers such that f of x minus 6 into f of 1 by x equal to 35 by 3x minus 5 by 2. It's a functional equation. This kind of questions are seen in other chapters also. They can ask in application of derivatives or in differentiation or in integration. They can ask these kind of questions. It's called as functional equation. Okay. So question based on the functional equation. Limit x tends to 0 of this equal to beta. Find alpha plus 2 beta. Okay. So now my aim is to find f of x first. What is my f of x? We don't know, correct? The function f of x I have to find out. That is your first step. So f of x, what is given here is f of x minus 6 into f of 1 by x, correct, is equal to 35 by 3x, 35 by 3x minus 5 by 2. This is given. I will get another equation using this. by replacing x by 1 by x. Because when you replace x by 1 by x, what happens? X will become 1 by x and 1 by x will become x. So we'll replace x by 1 by x and we'll solve the two equations simultaneously so that I can find the value of, or I can find the function f of x. Function f of x can be found. Once you get the function f of x, you can substitute here and you can evaluate the limit. You can find the values of alpha and beta by the known methods. So my aim is to find the function f of x. Same kind of question can be asked in differentiation or in application of derivatives, increasing and decreasing function, or maxima, minima, such kind of questions they can ask. Even in integration they can ask definite integrals, or in indefinite integrals. Anyway they can ask. Learn this method of finding the function, okay? So because there is f of x and f of 1 by x, what we do? We get another equation so that that equation also contains f of x and f of 1 by x. Okay, so that we can solve the two equations simultaneously. Replacing x by 1 by x, what do we get? F of x becomes 1 by x minus 6 into f of 1 by x will become x is equal to 35 by 3x. Here x in denominator, no? That will become 35 by 3 into x. X will be in the numerator minus 5 by 2. My aim is to find f of x. So we'll eliminate f of 1 by x. Okay. So what we'll do is now multiply the second equation by 6 and add the two equations so that 6f of 1 by x will add up to 0. Multiply this by 6. Multiply this by 6. What we get? 6 into f of 1 by x minus 36 f of x, correct? Here 3 1s are 3 2s are becomes 35 into 2, 70x minus 2 1s are 2 3s are 3 into 5, 15. Okay, add these two equations, equation 1 and equation 2. Adding equations 1 and 2, what we get? Adding 1 and 2, adding equations 1 and 2, what we get? Find out. 6 f of 1 by x will add up to 0, correct? Minus 36 f of x plus f of x minus 35 f of x minus 35 f of x is equal to 70x plus 35 divided by 3x, correct? Minus 15 minus 5 by 2. 5 by 2 is 2.5. So it becomes, this is minus 30 by 2 minus 5 by 2. Minus 35 by 2 I can write. Minus 35 by 2. So you can divide the entire equation by minus 35, correct? So I'll get f of x. I'll get f of x is equal to dividing by minus 35. This will become minus 2x. Dividing by minus 35. Dividing by minus 35. This becomes minus 1 by 3x. This will become plus 1 by 2. F of x I got. And you can substitute here. What is given there? Limit x tends to 0. Limit x tends to 0. 1 by alpha x. 1 by alpha x plus f of x is given to be equal to beta, right? So there you substitute the value of f of x, what we got. Correct? Therefore, what do you get? Limit x tends to 0. Limit x tends to 0. 1 by alpha x plus f of x, what we got? Minus 2x minus 1 by 3x plus 1 by 2 is equal to beta. From this, limit x tends to 0. Limit x tends to 0. Collect the terms with 1 by x. Okay. 1 by x terms you collect. 1 by x if you collect, what I'll get is 1 by alpha minus 1 by 3. Correct. Then minus 2x plus 1 by 2 is equal to beta. Beta is a real number. Even alpha and beta both are real numbers. Correct. So now for limit to exist, if you apply limit, no, this becomes 1 by 0. 1 by 0 means limit does not exist because beta is already a real number. That's indication of limit of this function is going to exist finitely. Correct. So for limit to exist, we insist the condition that this term should become 0. Okay. 1 by alpha minus 1 by 3 becomes 0. So that takes 0 by 0 form. If you take 0 by 0 form, we can evaluate by using L'Hopital's rule. So we insist the condition that 1 by alpha minus 1 by 3 is equal to 0. That means 1 by alpha equal to 1 by 3. So alpha equal to 3 I'll get. Taking reciprocal, I get alpha is equal to 3. And this already became 0. And when you apply limit for this, this becomes 0, no? 2 into 0 is 0. This part is becoming 0. Correct? So beta is going to be equal to half. If I apply the limit, what I'm getting is beta is equal to half. Finally, what I want to find is alpha plus 2 beta. Therefore, alpha plus 2 beta is equal to alpha how much? 3 plus 2 into beta is 1 by 2. 2 into half is 1. 3 plus 1 is equal to 4. So required answer is 4. Option C. Finding out the function f of x by replacing x by 1 by x. And the given equation and the equation you got after replacing x by 1 by x, solve them simultaneously and find the function f of x. That f of x is substitute there. Okay, and simplify. Alpha plus 2 beta I'll get. By known methods, evaluate the limit. So answer is 4. Option C. Solution is also given to you here. Move on to the next one. Question number 4. Limit x tends to 0. Cosec x into square root of 2 cos square x plus 3 cos x minus root of cos square x plus sin x plus 4 equal to how much? Question asked on 24th of January 1st shift 2025. Okay. See, as x approaches 0, cosec x will approach to infinity, we know, correct? As x approaches to 0, cosec function will approach to infinity. This is becoming infinity. This is approaching infinity. What about this terms inside the bracket? Cos 0 is 1. Cos 0 is 1. 2 into 1 square plus 3 into 1. This becomes root 5. Here, cos 0 is 1. 1 square is 1. Sin 0 is 0. 1 plus 0 plus 4. Root 5. Root 5 minus root 5 is 0. It takes infinity into 0 form. Takes which form? Infinity into 0 form. Which is an indeterminate form. Correct? Cosec 0 is approaching to infinity. Correct? As x approaches to 0, cosec x is approaching infinity, we know. And as x approaches to 0, root of 2 cos square x plus 3 cos x is approaching root 5. Root 5 minus root 5 is becoming 0, correct? So root of cos square x plus sin x plus 4. This is approaching 0, correct? Becomes root of 2 plus 3, 5. Cos 0 is 1, correct? Cos 0 is 1, cos 0 is 1, cos 0 is 1, sin 0 is 0. 2 into 1 square, 2 plus 3, 5. Root 5 minus root 5 is approaching 0. Takes infinity into 0 form. Because there is square root involved here, normally we go by method of rationalization. Multiply and divide by the conjugate of that. So to evaluate this limit, what I'll do is I'll rationalize. Limit x tends to 0. Cosec x into what we have? Root of 2 cos square plus 3 cos. We can use a shortcut, all these things like I can't write all the steps in the exam, right? You should be very fast, extremely fast. We can use instead of cos square, you can write c square. Yes means you can write sine, and you should keep it in mind. C is what, yes is what. Such things you can do. Okay. All the exam tips we'll give later. First we'll learn the methods of limits. All the PYQs we are practicing now, correct? Plus sin x plus 4. You multiply and divide by the conjugate of this. Multiply and divide by what? Root of 2 cos square x plus 3 cos x plus root of cos square x plus sin x plus 4. Multiply and divide by the conjugate. Root of 2 cos square x plus 3 cos x plus root of cos square x plus sin x plus 4. Numerator I can use a minus b into a plus b, which is a square minus b square, correct? A minus b into a plus b is a square minus b square. Apply that. And for denominator we can apply limit here. As x approaches to 0, cos 0 is 1, correct? Cos 0 1, 2 into 1 square plus 3 into 1. This is approaching root 5. And this also becomes root 5, correct? Cos 0 is 1, sin 0 0, 1 plus 0 plus 4, 5. So root 5 plus root 5. Denominator is 2 root 5. Keep it outside, 1 by 2 root 5. And I'll convert this infinity into 0 form to 0 by 0 form, correct? This you can keep outside. Root 5 plus root 5 is 2 root 5. 1 by 2 root 5 I'll write. 1 by 2 root 5. So cosec x I'll write 1 by sin x. Here what is left in the numerator? Applying the formula a minus b into a plus b, a square minus b square. So I'll write without root. A square means you're squaring this. Without root you should write. So what do you get? 2 cos square x plus 3 cos x minus of cos square x plus sin x plus 4. Correct? Divided by sin x. Here 2 cos square x minus cos square x is cos square x. Simplified. What we get? 1 by 2 root 5. Limit x tends to infinity. No, x tends to 0. No, it is. Sorry, I mistake it out. X tends to 0. X tends to 0. What we have? 2 cos square x minus cos square x is cos square x plus 3 cos x minus sin x minus 4. Correct? Open the bracket. Minus into plus is minus. Divided by sin x. Now it is taking 0 by 0 form. I am converting infinity into 0 form to 0 by 0 form. So that I can apply L'Hopital's rule. Correct? A familiar L'Hopital's rule also they call. So if you apply limit directly, denominator is becoming 0. Sin 0, 0. Cos 0, 1. Cos 0, 1. Correct? 1 plus 3, 4. Sin 0, 0. 1 plus 3, 4. 4 minus 0, 4. 4 minus 4, 0. Now it takes 0 by 0 form. It takes 0 by 0 form at this stage. I can apply L'Hopital's rule. Okay. Differentiate numerator and denominator separately. I'll write here itself. That's equal to 1 by 2 root 5. 1 by 2 root 5. Limit x tends to 0. Limit x tends to 0. Differentiate numerator and denominator separately. Derivative of cos square x. 2 cos x into derivative of cos x minus sin x by chain rule. Correct? Derivative of x square is 2x. No, likewise. Derivative of cos square x. 2 cos x into derivative of cos x minus sin x. You can write minus sin 2x directly. 2 cos x into derivative of cos x minus sin x. And derivative of 3 cos x is minus 3 sin x. Correct? Derivative of minus sin x is minus cos x. Derivative of 4 is 0. Denominator. Derivative of sin x is cos x. Now I can apply limit for everywhere. We'll get the answer. See, sin 0 is 0. Correct? This part is gone. As x approaches to 0, this part is gone. 0. And sin 0 is 0. Here also 0. This is becoming 0. This is becoming 0. Cos 0 is 1. So minus 1. Here also cos 0 is 1. Correct? Minus 1 by 1. So minus 1. So get the answer as minus 1 by 2 root 5. 1 by 2 root 5 into, this is becoming 0. Sin 0 is 0. Sin 0 0. Cos 0 1. So minus 1 divided by cos 0 is 1. So answer is minus 1 by 2 root 5. Option D is the answer. Minus 1 by 2 root 5. Simple question. Many times this type of question already appeared. If you practice the PYQs, the first preparation for JEE should be learning all the formulas and writing those formulas without seeing. Make a notes of your own. Okay. Write and study all the formulas. Make a habit of writing all the synopsis part on your own. First study and write without seeing. Then practice all the PYQs. It's more than enough. If you finish at this much of revision, studying all the formulas and practice the PYQs, not once or twice, you should practice minimum 3 times all these questions. Okay. Then only you'll get the grip in the subject. And many times similar type questions will be asked. This type of question already we done in the past also. Maybe in 2019-20 also these type of questions have been asked. Okay, I can give you guarantee about this. Question is done. Answer is minus 1 by 2 root 5. Simple question. Level 1 kind of question. Okay. On to the next one. Question number 5. Let box of t be the greatest integer less than or equal to t. Find the least value of p belonging to natural number for which this inequality is satisfied. This is a question based on sandwich theorem, and you must know the greatest integer function in terms of fractional part function. There are two methods of solving this problem. I can do it by using the properties of greatest integer function, or else I can use the greatest integer function in terms of the fractional part function and do. Any method you can do. Okay, I'll do both the methods if you want, and also I'll give you the time saving result for this. And this type of question is already asked in 2018 JEE Main. Okay, during that time it was not online exam, and 2018 it was offline exam. 2019 onwards they started conducting computer based test, CBT we call. Okay, so many shifts were there and we get many questions now. From 2019 onwards, NTA, National Testing Agency, have been started conducting the exams for JEE Mains. Okay, so this question here you can see the greatest integer function 1 by x, greatest integer value of 2 by x, etc. Here greatest integer value of 1 square by x square, greatest integer value of 2 square by x square, all those things. I'll do it by two methods. Okay, so first method I'll use in terms of the fractional part function. You must know that greatest integer function x is equal to x minus fractional part function, x minus greatest integer function, correct? Greatest integer function is x minus, yeah, so fractional part function I can write x minus greatest integer function, or x minus fractional part function I can write like this. Okay, I'll be using this. Greatest integer value of x is x minus fractional part function. I'll be using this method to find the value. Okay, or I can write fractional part of x is x minus greatest integer function, both one and the same. So limit x tends to 0 plus we have, I'll evaluate this separately and evaluate this separately. Okay, so first you can apply limit for this, then apply limit for this. So you concentrate on this. We know that greatest integer value of 1 by x, greatest integer value of 1 by x equal to 1 by x minus fractional part of 1 by x. Using that, greatest integer value of x is x minus fractional part of x. Likewise, greatest integer value of 2 by x is equal to 2 by x minus fractional part of 2 by x. Like this. Go on, continue. Lastly, we have greatest integer value of p by x is equal to what? P by x minus fractional part of p by x. Okay, just applying this definition of greatest integer function in terms of fractional part function. Now we add all these things. Sum is there, no? So add up all these things and you multiply by x. Then put the limit for that. Okay. So adding all these equations, what do you get? Integral value of 1 by x plus integral value of 2 by x, etc. Integral value of p by x is equal to, add all the right hand sides, what do you get? 1 by x plus 2 by x plus 3 by x, etc. p by x, adding all these things, minus of, yeah, fractional part of 1 by x plus fractional part of 2 by x, etc. fractional part of p by x. The flower bracket denotes the fractional part function, like this. Okay, now multiply all of them by x, then apply the limit. If you multiply by x, here itself I'll write multiply by x for this, multiply by x for this, multiply by x for this. Okay, now take limit of this. Limit x tends to 0 plus. Take limit x tends to 0 plus of this. Limit x tends to 0 plus of x into greatest integer value of 1 by x plus greatest integer value of 2 by x, etc. greatest integer value of p by x is equal to, here x is common denominator, no? X will cancel with this numerator, correct? This becomes summation of p, 1 plus 2 plus 3, etc. p. When you apply limit of a constant is constant. Take x as common denominator and cancel that x and the numerator x. So what is left is 1 plus 2 plus 3, etc. p. Sum of the first p natural numbers, which is p into p plus 1 by 2. If you apply limit also, limit of a constant is constant. It becomes p into p plus 1 divided by 2, correct? And for this, when you apply limit, now this becomes equal to 0 here. Limit of this is going to 0 because fractional part function always lies between 0 and 1. I can use sandwich theorem and prove this. See, fractional part function, you must know that it is always lying between 0 and 1. Fractional part function always lies between 0 and 1, including 0, excluding 1. So fractional part of 1 by x, where it lies between 0 and 1. Fractional part of 1 by x, it lies between 0 and 1. Fractional part of 2 by x, where it lies between 0 and 1, including 0, excluding 1. Where it is fractional part of p by x, fractional part of p by x also lies between 0 and 1. You must know the range of the fractional part function. So you add all these things and multiply by x, correct? And I can use sandwich theorem and get the answer. Adding all these things, I'll get 0 less than fractional part 1 by x plus fractional part 2 by x. Like this goes on. Fractional part of p by x is less than 1. Multiply by x for all. Okay? Less than or equal. Multiply by x. 0 into x, 0. Less than or equal to x into this entire thing. Less than. Multiplying by x, no, this will become x. 1 into x is x. Correct? This is fractional part 1 by x plus fractional part 2 by x. Like this it goes on. Fractional part of p by x. Like this. Adding all the p inequations, get like this. Multiply by x. 0 into x, 0. Here also multiply by x. Multiply by x. Now take limit of this. Limit x tends to 0 of this is 0. Take limit of this. Limit x tends to 0 plus of x into fractional part of 1 by x plus fractional part of 2 by x. Like this it goes on. Fractional part of p by x. Less than. Take limit of this. Limit x tends to 0 plus of x. That is going to be 0. So this is sandwiched between this and this. Limit of this is becoming 0. Limit of this is becoming 0. So limit of the middle one is also 0. That is what we got. This is by sandwich theorem I got this. So I can remember this. You can take it as a shortcut also for this. Okay. Limit x tends to 0 plus x into bracket integral value of 1 by x plus integral value of 2 by x plus integral value of 3 by x, etc. Integral value of p by x is nothing but summation of p. Summation of p. Likewise you can do for this. Same story for this. X square is there and inside the bracket we have integral value of 1 square by x square, 2 square by x square, like that goes on. Integral value of 9 square by x square. That will be summation of 9 square. Okay. So more generally you can learn this as a result. So limit x tends to 0 plus of x into what we have integral value of 1 by x plus integral value of 2 by x, etc. goes on till integral value of p by x. What is the answer for this? Remember, it is nothing but p into p plus 1 divided by 2. Summation of p. Remember this as a time saving result so that you can answer directly. And what about this limit x tends to 0 plus? Suppose I give limit x tends to 0 plus x square into integral value of 1 square by x square plus integral value of 2 square by x square. Like this it goes on. Integral value of p square divided by x square. That is going to be summation of p square. Summation of p square, which is nothing but p into p plus 1, 2p plus 1 by 6. Okay. This is going to be p into p plus 1 into 2p plus 1 divided by 6. Summation of p square. So here up till 9 square you can see. This will become summation of p square. If you solve this, I'll write here itself. Limit of this is what? P into p plus 1 by 2. P into p plus 1 by 2. Minus. Limit of this. We can see up till 9 square. So put p is equal to 9 in this end, right? What is, when you put p is equal to 9 in this? Put p is equal to 9. 9 into 9 plus 1, 10. Correct? Into 2 into 9, 18 plus 1, 19. Divided by 6. You can cancel. 3 2s are 3 3s are. 2 1s are 2 5s are. What you get is 15 into 19, which is 285. 285 I get. Okay, limiting value, that will be 285 is greater than or equal to 1. And you have to solve this. You have to solve this and get the natural number p, the least value of p, a natural number you have to get. And you have to solve this inequality, get a quadratic inequality here. If you solve this, what I'll get is multiply the entire inequation by 2. If you multiply by 2, I'll get p square plus P, correct, open the bracket, minus 285 into 2, that is 570, greater than or equal to 2, or P square plus P minus 572 I'll get. I'll write here P square plus P minus 572 greater than or equal to 0. Like this I'll get. And you know how to solve the quadratic inequality. First find the roots of that by using the formula method, and by using Vevicom method I can conclude. Okay, I shall solve this equal to 0 and find the roots, actual roots of that equation, quadratic equation. P square plus P minus 572 equal to 0 by using the formula method, minus B plus or minus root of B square minus 4AC divided by 2. Using that formula, if you find out, I'll get P is equal to minus 1 plus or minus root of B square. 1 square is 1 minus 4AC, minus 4 into minus 572. I'll get 2289. Okay, 2289 divided by 2 into 1. So minus 1 plus root of 2289 by 2. And another one is minus 1 minus root of 2289 by 2. So if you can write this in terms of the linear factors, I can write this as P minus of minus 1 minus of root of 2289 divided by 2. This is one linear factor, and another linear factor is going to be P minus 1 plus root of 2289, okay, divided by 2. Like this will get. This should be greater than or equal to 0. This should be greater than or equal to 0, and we'll get the Vevicom method. You can apply the critical points. You can take it as approximately. You can find the value of this. If you take 47 square, no, it is 2209. 47 square, right here, 47 square is 2289. Okay, 47 square is 2289. I think 47 square. I think 2209. I think 2209. Okay. Sorry, 2209, 47 square, and 48 square also I'll write down. 47 square is 2209, and 48 square is 2304. Okay, you must know these values, so that approximately I can tell that 2289 is 47.84. Okay, 47.84. 47.84 minus 1, 46.84, 46.84 by 2, 23 point I'll get, 23.42, and this will be minus 47.84 minus 1, minus 48.24, correct, minus 48.24 by 2, that is going to be 24.21. So if you use the Vevicom method, I got the value of P. One value of P is minus 1 plus root of 2289 divided by 2. Another value of P, if you take equal to 0, I'm telling, minus root of 2289 divided by 2. This is approximately 2289 is 47.84 minus 1, 46.84, 46.84 by 2, 23.42 approximately. And this is approximately minus 47.84 minus 1, minus 48.84, minus 48.84 by 2, minus 24.42. Like this will get. Okay. So if you represent this on the number line extends from minus infinity to plus infinity, and I can represent these numbers: minus 24.42, 23.42, correct. Right side you start, you see the coefficient of P square is 1, right? Coefficient of P square is 1 here. If you solving this quadratic inequality, correct, coefficient of P square is 1. So you start from right side of 1, start from right side of this 23.42, that is going to be positive, and 23.42 is nothing but this value. Okay, that is derived from minus 1 plus root of 2289 by 2 is derived from where? It is derived from this, correct? P minus. The power of this is 1. Here also the power is 1. Both the powers are odd number. By using Vevicom method, By wavy curve method, I can tell the sign changes, correct? Alternate plus minus, because the power is odd number, plus becomes minus. And here this is derived from the factor p minus of this value. Its power is also odd number, so sign changes. So where it is positive and where it is negative, we know, correct? So I'm using this x minus a into x minus b is greater than 0, greater than or equal to 0. In other words, x belongs to the interval minus infinity to a union b to infinity. We can use this where a is a smaller number than b. Okay. And p belongs to this interval. P belongs to which interval? Minus infinity to minus 24.42 union 23.42 to infinity. They asked to find the least natural number p satisfying the inequality. So natural number doesn't come in this. Natural number starts from 1, no? So it has to come here. So least value of natural number p is 24. The least value of p belonging to n is 24. Least value of p belonging to n, natural number, is 24, correct? That's the answer. Numerical type question. So if you want, I'll add one more slide and write in detail whatever we've done here. Okay. That is, you can make a note of this. Limit x tends to 0 plus, limit x tends to 0 plus of x into integral value of 1 by x plus integral value of 2 by x, etc. Integral value of p by x. That we got it as summation of p. Summation of p is what? P into p plus 1 divided by 2. P into p plus 1 divided by 2. Limit x tends to 0 plus x square into what we have? Integral value of 1 square by x square, correct? Integral value of 2 square by x square. Like this it goes on. Lastly we have integral value of p square by x square. 9 square by x square was there. That becomes summation of 9 square. That becomes summation of 9 square. Summation of 9 square means 9 into 9 plus 1 into 2 into 9 plus 1. That is 19 divided by 6. We got the answer as 285 for this. Okay. And we're solving the inequality here. That is, we're solving this inequality. This value is summation of p into p plus 1 by 2. This value is summation of 9 square, which is 285. So we are solving this inequality, p square plus p minus 570 greater than or equal to 2. That is, given expression becomes p into p plus 1 by 2, correct, minus 285 greater than or equal to 1. From there I got p square plus p minus 572 is greater than or equal to 0. If you use the formula method for this, p square plus p minus 572 equal to 0, you take and solve, we get p is equal to what? Minus b plus or minus root of b square minus 4 into a into c divided by 2a, correct? That is minus 1 plus or minus root of 572 into 4 is 2288 plus 1 2289 you get. 2289 divided by 2. And I can split this as the product of two linear factors. What is that? One factor is p minus 1 minus root of 2289 divided by 2. This is one linear factor. And another linear factor is p minus of minus 1 plus root of 2289 divided by 2 greater than or equal to 0, like this. Minus 1 plus root of minus 1 minus root of. This value is approximately I wrote, that is minus 24.42, correct? I wrote it as minus 24.42 and that is 23.42, correct? This is actually roughly equal to 47.84. 47.84 minus 47.84 minus 1, 48.84 minus 48.84 by 2 minus 24.42. This is also approximately 47.84 minus 1, 46.84. 46.84 by 2, 23.42, and represent it like this. Okay, using the wavy curve method, we can represent this, and one value is here, another value is here. Okay, this value is 23.42 and that is minus 24.42. This is minus 24.42. This is value I wrote here and this value is written here. This value is minus 24.42, approximately I'm telling. This value is 23.42 and you start from right side of this 23.42, it is positive because coefficient of p square is 1. If coefficient of p square is positive, you start from the right side of this 23.4, the right side of the highest value. Highest value is 23.42, correct? The critical point I can call. These are the critical points. Okay, right side of 23.42 you take positive and the 23.42 is derived from this, correct? Its power is 1. 1 is odd number. Odd number means sign changes when it comes this side, negative. This is got from this factor, correct? It's derived from this factor. If we equate this factor to 0, I'm getting this as a critical point. So the power, this is derived from this factor. Its power is 1, odd number. Odd number means the sign is going to change again. Minus will become plus. That's called Wavy-Cow method. Suppose the power was even number, then sign doesn't change. That's Wavy-Cow method. I explain to you in detail, okay, later. So we got the value of P as 23. Natural number is 24. We got like this. The interval is like this. Here there is no natural number and here there is natural number comes from 24 onwards. The least value of P, which is a natural number, is 24. That is what the question asked. Okay. So in detail I have given it, the solution. Okay. Question asked on 29th of January, first shift, 2025. Solution is also given to you here. Okay, note down this. Next one, question number 6. F of x is given as limit n tends to infinity, summation r equal to 0 to n, tan of x by 2 power r plus 1 plus tan cube of x by 2 power r plus 1 divided by 1 minus tan square of x by 2 power r plus 1. To find limit x tends to 0, e power x minus e power f of x divided by x minus f of x. Question was asked on 28th of January, second shift, 2025. So you can see that everywhere there is x by 2 power r plus 1. Okay, we should name it as some angle theta and try to simplify this trigonometric function first and you apply summation for that. Then apply limit for that. Then you'll get f of x. After getting f of x, substitute that. Then find the limiting value of that. So much you should do. First simplify this trigonometric function using trigonometric formulas or trigonometric identities. First simplify the function f of x. Then apply the summation. Then take limit n tends to infinity for that. You'll get f of x. Understood? Then substitute that f of x in this. Then find the limiting value of that. As x tends to 0, what is the limiting value to find out? So, one by one we shall do. For simplicity's sake, we shall put x by 2 power r plus 1 as theta. Put theta is equal to x by r power 2 plus 1. Theta is equal to x by 2 power r plus 1. So, the given expression becomes what? Tan theta plus tan cube theta by 1 minus tan square theta. Correct? That is tan theta plus tan cube theta divided by 1 minus tan square theta. That is equal to tan theta can take common, no? The numerator tan theta is common. Tan theta is taken out means what you get is 1 plus tan square theta divided by 1 minus tan square theta. We know 1 minus tan square theta by 1 plus tan square theta is cos 2 theta, double angle formula we have, correct? Cos 2 theta is equal to what we know? Cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. Now the reciprocal of this is present here, 1 plus tan square theta by 1 minus tan square theta. So that will be 1 by cos 2 theta. That is tan theta divided by cos 2 theta, denominator 1 by cos 2 theta. Tan you can write sin by cos, correct? So this will be sin theta divided by cos theta divided by cos 2 theta. That is equal to sin theta divided by cos theta into cos 2 theta. I am trying to simplify this. This cos theta comes to denominator, correct? The reciprocal of cos 2 theta is present. So 1 by cos 2 theta is 1 plus tan square by 1 minus tan square. Tan I wrote sin by cos. That cos will come to denominator. and we'll write theta as 2 theta minus theta, sine of 2 theta minus theta divided by cos theta into cos 2 theta, correct? Sine theta is sine of 2 theta minus theta. Sine of a minus b formula we can expand, correct? Compound angle formula, applying sine of a minus b, sine a cos b minus cos a sine b. This is equal to what? Sine 2 theta into cos theta minus cos 2 theta into sine theta divided by cos theta into cos 2 theta, correct? Expanding it, sine of a minus b, sine a cos b minus cos a sine b. Separate the terms, cos theta will cancel, divide this by this, divide individually, separating the terms. Sine 2 theta cos theta by this, cos theta will cancel, sine 2 theta by cos 2 theta is tan 2 theta, correct? Minus, divide this by this, cos 2 theta is going to cancel, sine theta by cos theta is tan theta. So we get tan 2 theta minus tan theta we get. So the trigonometric part is simplified. Theta you substitute back, theta is what? X by 2 power r plus 1. So applying limit n tends to infinity, f of x is limit n tends to infinity, summation of r is equal to 0 to n, correct? What we get? Put theta back, theta is what? X by 2 power r plus 1. So 2 theta will be what from this? 2 theta means you multiply by 2 on both sides, that will be x by 2 power r, because 1 2 will cancel when you multiply by 2. 2 power r plus 1 is 2 power r into 2 power 1. So 1 2 will cancel, I get x by 2 power r. So tan 2 theta will be x by 2 power r. Tan of is it, sorry, tan is it, tan of x by 2 power r minus tan of x by 2 power r plus 1. For this I should apply the summation. Put r equal to 0, r equal to 1, etc. till r equal to n, then n tends to infinity. Many of the terms will cancel here. This is equal to limit n tends to infinity, applying summation, putting r equal to 0, x by 2 power 0, 2 power 0 is 1. So this becomes tan x, correct? 2 power 0, 2 power 0 is 1, x by 1 is x, tan of x by 1 minus tan of x by, put r equal to 0, 0 plus 1 is 1, correct? 2 power 1. This is first term. Next term is tan of x by 2 square, tan of x by 2 power r is 1, correct? 2 power 1 minus tan of x by 2 power 2 it becomes, putting r is equal to 1. Like that you go on, continue. Next last term will write tan of x by 2 power n minus tan of x by 2 power n plus 1, putting r is equal to n, correct? Like this. Now see, tan x by 2 will cancel. Next, tan x by 2 square will cancel. Like that. Last but one term will be tan of x by 2 power n minus 1 minus tan of x by 2 power n. So this will cancel. And as n tends to infinity, 2 power n plus 1 also tends to infinity. N is approaching infinity, n plus 1 also infinity, and 2 power infinity is infinity. Note that as n tends to infinity, 2 power n plus 1 is approaching infinity, because 2 is a number greater than 1. Greater than 1 power infinity is infinity. If a number lies between 0 and 1 power infinity is 0. We know all those things. So 2 power infinity is infinity. So x by 2 power n plus 1 tends to 0. Correct? X by 2 power n plus 1 will tend to 0. So this will become 0. This part is approaching 0. Explained here in detail. Correct? So tan of something by infinity is 0, tan 0 0. Rest all terms have been cancelled, so simplifies to tan x. My f of x is tan x. Finally I got f of x equal to tan x. Now I can substitute here, f of x I got tan x. Limit x tends to 0 of this I have to find out. Limit x tends to 0, e power x minus e power, f of x is tan x. F of x is tan x divided by x minus tan x is equal to limit x tends to 0, take e power tan x out, even though it's not common I'm taking out, balance it by dividing by e power tan x, e power x by e power tan x minus 1 divided by x minus tan x. And for this I can apply the limit. For this you can apply limit. Tan 0 is 0, right? Tan 0 is 0. E power 0 is 1. E power 0 is 1. So I'll write the answer here. That's equal to e power 0. Correct? I apply limit for this. What is left is limit x tends to 0. Limit x tends to 0. E power x by e power tan x. Is e power tan x. E power x by e power tan x. E power x minus tan x. Correct? E power x minus tan x minus 1 divided by x minus tan x. Correct? And see, the x approaches 0 means x minus tan x also approaches 0 because tan 0 is 0. As x approaches to 0, x minus tan x is approaching 0, right? Because tan 0 is 0. The power and the denominator both are approaching to 0 and both are same. Correct? X minus tan x, the power and denominator both are same. So both are approaching to 0. I can use the limit theorem. Limit x tends to 0, e power x minus 1 by x1, limit of exponential function. So this value is 1. E power 0 is 1. 1 into 1 is equal to 1. The required answer is 1. Using this, limit x tends to 0, e power x minus 1 by x is 1. E power x minus 1 by x is equal to 1. The power and the denominator should be same and both are approaching to 0. Correct? Both are approaching to 0 and both are same. X minus tan x. The power and denominator are same. X minus tan x is approaching to 0. So that part is 1. This part is becoming 1. 1 into 1 is 1. Hence the answer. Hope you understood this. First simplify the trigonometric function, then apply summation, then take limit n tends to infinity, we get f of x. That f of x is substituted there to get the answer. Solution is also given to you here. Move on to the next one. Question number 7. Question asked on 29th of January, second shift 2025. Integration sign is there. See how to do this. Can you try? Limit t tends to 0 is that. Integral from 0 to 1, 3x plus 5 to the power t dx power 1 by x. For integration, the variable is x. Okay. And the limit is t tends to 0. Limit is t tends to 0. For integration, the variable is x. And the power is 1 by t. As t approaches to 0, 1 by t approaches to infinity. The power is becoming infinity. And when you apply the limit for this, 3x plus 5 to the power 0. Power 0 is 1. Anything to the power 0 is 1. So this is becoming 1. When you integrate also, this becomes 1 only. Correct? As t tends to 0, as t is approaching 0, what happens? 3x plus 5 to the power t is approaching 1. And integral of 1 is 1. When you integrate 1, we get x. Limits from 0 to 1, correct? Suppose you're integrating this. This part I'll show. This part. 3x plus 5 to the power t is 1. Correct? This becomes integral from 0 to 1, 1 dx. Integral of 1, x. Limits from 0 to 1. That means it is becoming 1 minus 0, 1. So the base is approaching 1 and the power is becoming infinity. It takes 1 to the power infinity form, correct? 1 by t is approaching 0. So the given integral, given expression takes 1 to the power infinity form. Takes 1 to the power infinity form. The base is approaching 1 and the power is approaching infinity. So typical problem for JEE, 1 to the power infinity form. E power limit g of x into f of x minus 1. Apply that. That's equal to what? So that's given to be equal to alpha by 5e into 8 by 5 to the power 2 by 3. Want to find alpha. So I'll evaluate this and compare with this right hand side. So I'll start from e power limit t tends to 0. What we have? The power you write first, 1 by t into what we get? Integral from 0 to 1, 3x plus 5 to the power t dx minus 1. Correct? E power limit power you write into base minus 1. Now integrate this. You can treat t as a constant here because the integration, no, for integration the variable is x. For integration variable is x, so I am treating the t as a constant, correct? So you can apply the formula like integral of x power n. It is like integral of x power n. What is integral of x power n? X power n plus 1 by n plus 1, right? So integrate this with respect to x, keeping t as a constant. So I'll get this is equal to e power limit t tends to 0, 1 by t into here integral of 3x plus 5 to the power t will be 3x plus 5 to the power t plus 1 divided by t plus 1 and divide by coefficient of x. After integrating, I should divide by coefficient of x. Divided by 3, that comes to denominator only, into 3 I'll write here. Correct? Limits from 0 to 1 for that. Limits from 0 to 1 for this. 0 to 1 minus 1. That's equal to e power limit t tends to 0, 1 by t into, here apply the limit, put x equal to 1. When you put x, the variable for integration is x, so put x equal to 1, apply the upper limit minus lower limit, substitute the value of substitute the upper limit for the given variable x and put the lower limit. Evaluate the function at upper limit minus evaluate the function at lower limit. When you put x equal to 1, 3 into 1, 3, 3 plus 5 is 8. You get 8 to the power t plus 1 divided by 3 into t plus 1, correct? Minus lower limit is 0. When you put lower limit is 0, 3 into 0, 0, 0 plus 5 is 5, 5 power t plus 1, 5 power t plus 1 divided by 3 into t plus 1 minus 1. Simplify this now. Take a common denominator as 3 into t plus 1. Common denominator we can take and simplify it. E power, what we have? Limit t tends to 0. Taking common denominator as 3 into t plus 1. What I'll get? I can take 1 by t into, here taking the common denominator as 3 into t plus 1, this will be 8 power t plus 1 minus 5 power t plus 1 minus of 3 into t plus 1, taking common denominator, correct? Then now if you apply limit, now what happens you see, it is taking 0 by 0 form I can tell. When you put t equal to 0, 0 plus 1 is 1, 8 power 1 is 8, correct? Here 5 power 0 plus 1, 5, 8 minus 5 is 3, 3 into 0 plus 1, 3, 3 minus 3, 0, denominator also becoming 0, takes 0 by 0 form. So we can apply L'Hopital's rule. We can differentiate numerator and denominator separately here. So what we can do is we can multiply this t inside and differentiate numerator and denominator separately and apply the limit for this. T tends to 0 is there, correct? So that will be e power limit t tends to 0, derivative of a power x formula, a power x into log a, using that concept, simplify it, okay? That will be e power limit t tends to 0, e power limit t tends to 0. What we have? Differentiate the numerator and denominator separately and apply the limit for that. Derivative of 8 power t plus 1 will be what? 8 power t plus 1 into log 8. Derivative of t plus 1 with respect to t is 1. Derivative of 5 power t plus 1 is 5 power t plus 1 into log 5. Derivative of t plus 1 is 1 minus 3 into derivative of t plus 1 is 1. Correct? Denominator will be what? If you differentiate t, you multiply it inside, then write 3 into t into t is t square. Derivative of t square is 2t. Correct? And t into 1 is t. Derivative of t is 1. Now you can apply the limit for this. Put the limit, what we get? This is equal to e power, apply the limit at this stage, no harm in applying the limit, 8 power 0 plus 1, that is 8 log 8, I'll get 8 log 8 minus 5 power 0 plus 1, that is 5 log 5, 5 log 5, 5 log 5 minus 3, correct, divided by 3 into, this is becoming 0, 2 into 0 is 0, 0 plus 1 is 1, 1 into 3 is 3, correct, denominator when I apply limit, 3 into 0 plus 1, that is 3. Now I can separate the terms here, this is equal to, I can write this as e power 8 log 8 is log 8 power 8. You know this property, log m power n. N log m is log m power n. Correct? Is equal to log of m power n. So 8 log 8 is log 8 power 8. Log of 8 power 8 minus log of 5 power 5. Correct? Divided by 3. And minus 3 by 3 is minus 1. So I can separate this e power. Here you can use the property of log a minus log b, log a by b, 1 by 3 into log of 8 power 8 divided by 5 power 5, correct, into e power minus 1. And this 1 by 3 can be taken to the power, again using this property, n log m equal log m power n. This becomes e power log of 8 power 8 divided by 5 power 5 to the power 1 by 3 into e power minus 1, I can write 1 by e, exponential log will cancel out. We know that e power log x is x, e power log of f of x is equal to f of x, correct? Exponential log or inverse functions will cancel out. So f of x should be positive there, it is positive number here. So I can write this as what? E and log will cancel out, 8 power, I'll get 8 power 1 by 3, 8 into 1 by 3, the powers gets multiplied, 8 power 8 by 3 divided by 5 power 5 into 1 by 3, 5 by 3 into 1 by e is there. So what is given there? This is given to be equal to alpha by 5e into 8 power 2 by 3 divided by 5 power 2 by 3. I'll write this, I'll compare this equal to alpha by 5e, alpha by 5e, 8 power 2 by 3 by 5 power 2 by 3. 8 power 2 by 3 divided by 5 power 2 by 3. And if you multiply 5 into 5 power 2 by 3, that becomes 5 power 8 by 3. 5 power 5 by 3, correct? Because 5 is 5 power 1. 1 plus 2 by 3 is 5 by 3. So I'm equating these two. This is given in the question. I'm equating these two and getting the value of alpha now. Lastly, I'll write here the last part. That is what we got. 8 power 8 by 3. 8 power 8 by 3 divided by 5 power 5 by 3 into 1 by e. This is given to be equal to alpha divided by 5e is there. I'll write e first. E I wrote. E I wrote. Alpha by e I wrote. What is left is 8 power 2 by 3 is given in the question, correct? Divided by 5 into 5 power 2 by 3 is 5 power 5 by 3. Because 1 plus 2 by 3 is 5 by 3. Multiplying means if the bases are same, you can add the powers. 5 power 5 by 3 cancels. Correct? E cancels. What is left? Alpha is equal to 8 power 8 by 3 divided by 8 power 2 by 3. So I'll get alpha is equal to what? 8 power 8 by 3 divided by 8 power 2 by 3. 8 power 8 by 3 divided by 8 power 2 by 3. That is 8 power 8 by 3 minus 2 by 3. 6 by 3. 6 by 3 is 2. So 8 square. Answer is 64. Nice question. Mixing integration, definite integral with 1 to the power infinity form. Hope you understood this. Takes 1 to the power infinity form. Apply the formula e power limit power into base minus 1. Integrate this. The variable for integral is x. Integrate it. Divide by coefficient of x. Integrate. After integrating, apply the limits. Then evaluate it. Get the answer. And compare with the given expression. Alpha is 64 we get. 64 is the answer. Next one, question number 8. Here we can see a determinant here. Limit x tends to 0, f of x equal to lambda plus mu a plus vb. Determinant is given f of x. Find lambda plus mu plus v the whole square. Question asked on 24th of January, second shift, 2025. So take limit on both sides. Limit x tends to 0 f of x, and also I'll be using the properties of determinant here. Taking limit on both sides, limit x tends to 0 f of x is equal to limit x tends to 0 of this determinant a plus sin x by x. As you know, sin x by x approaches to 1 as x tends to 0, correct? 1 b a 1 plus sin x by x. We can apply limit for all the terms inside the determinant. Apply limit for all the terms inside the determinant. Limit x tends to 0, sin x by x is 1, we know. Limit x tends to 0, sin x by x is 1. Limit x tends to 0, sin x by x is 1, correct? So you can apply limit for all the terms inside the determinant. That is how you put the, that is how you evaluate determinant. Applying limit for it, determinant is apply limit for all the terms of the determinant. And I'll be using sin x by x is 1 as x approaches to 0. Sin x by x is 1 as x approaches, this is approaching 1. This is approaching 1. This is approaching 1. So what do you get? Determinant of, this is a plus 1, 1, b, a, 1 plus 1, 2. This is b, a, 1, b plus 1. Like this will get. Now you have to simplify it and compare lambda plus mu a plus vb. Then find lambda plus mu plus v the whole square. Simple question. You can use the property of determinant here. If you not learned the property, learn it. I'll be teaching all those things later. Just apply the property of determinant. Try to get more number of zeros or common factors so that expansion of determinant becomes easy. Okay. Apply R2 changes to R2 minus R1. R3 changes to R3 minus R1. Apply. What I'm doing is R2 changes to R2 minus R1. Apply R2. Second row changes to second row minus first row. Third row changes to third row minus first row. We'll apply this. So what we get? Applying these properties. First row keep as it is. A plus 1, 1, B. Second row changes to second row minus first row. A minus A plus 1, minus 1. 2 minus 1, 1. B minus B 0. Third row minus first row. A minus A plus 1, minus 1. 1 minus 1, 0. B plus 1 minus B, 1. Expand this determinant. You know how to expand the determinant. We'll expand along the first row. A plus 1 into, leaving first column first row, 1 minus 0, 1. Minus 1 into, leaving second column first row, minus 1 minus 0, minus 1. Plus B into, leaving third column first row, 0 minus minus 1 plus 1. That is equal to A plus 1 plus 1 plus B. I'm getting like this. Compare. This is A plus B plus 2. Compare with what? What is given? Lambda plus mu A plus VB. Correct? I'll write mu A first so that I can write the coefficient of A as mu. Mu will be 1 plus mu A plus VB plus lambda. This is given in the question. Correct? If you compare, lambda is a constant term. So constant term lambda is 2. And the coefficient of A is mu and coefficient of A is 1 there. So mu should be equal to 1. Mu is 1. And B is also 1. Comparing the coefficient of B. So therefore, what we want to find? Lambda plus mu plus V the whole square. That is 2 plus 1 plus 1 the whole square, which is 4 square is equal to 16. Simple question on determinant and limit. Applying limit to a determinant is apply limit for all the terms. Apply limit to this, apply limit to this. Everywhere you apply limit and use the fact that limit x tends to 0, sin x by x 1. This is 1, 1, 1. Simplify using the properties of determinant, using row operations. I simplify the determinant to get more number of zeros so that expansion of determinant becomes easy and evaluate. Answer is 16, option D. Solution is given to you. Move on to the next one. Question number 9. Want to find limit n tends to infinity, summation k equal to 1 to n, k cube plus 6k square plus 11k plus 5 divided by k plus 3 factorial. Here summation is there, factorial is there, then you should take the limit of this. Okay. So first we'll simplify the numerator part. Numerator is a familiar expression actually. K cube plus 6k square plus 11k plus 6 we know. Do you know this? What is the expression? Simplified form of k cube plus 6k square plus 11k plus 6. You must know this. It's very important simplified form. That is equal to k plus 1 into k plus 2 into k plus 3. Verify this if you want. Okay. If you multiply all these three factors, k plus 1 into k plus 2 will be k square plus 3k plus 2. K square plus 3k plus 2 into k plus 3 will give this. K cube plus 6k square plus 11k plus 6. Product of these two is how much? K square plus k plus 2k, 3k plus 2. Correct? That you multiply to k plus 3. K square into k, k cube. 3k into k, 3k square plus 3k square, 6k square. Multiply this to this, multiply this to this. Here you get 3k square, here also 3k square, 3k square plus 3k square, 6k square. Multiply 3k into 3, 9k, 2 into k, 2k, 9k plus 2k is 11k, and the constant term is 6 plus 6. Hope you understand. If you multiply k plus 1, k plus 2, k plus 3, we get this. It's a very important expression, useful here and there. So what is given there is plus 5, correct? So 5 you can write 6 minus 1. So simplify that expression. What is given? Limit n tends to infinity, limit n tends to infinity, summation of k is equal to 1 to n, correct? Numerator is actually k plus 1, k plus 2, k plus 3 minus 1, correct? K plus 1 into k plus 2 into k plus 3 minus 1 divided by k plus 3 factorial, like this, correct? Product of these three bracket is written here, k cube plus 6k square plus 11k plus 6 minus 1 will give this, correct? Because 6 minus 1 is 5. Hope you understand. So remember this expression, k cube plus 6k square plus 11k plus 6 is product of k plus 1, k plus 2 and k plus 3. So 5 is 6 minus 1. So it is tallied. Now you can separate the terms. K plus 3 factorial is k plus 3 into k plus 2 into k plus 1 into k factorial, correct? So I'll simplify. Limit n tends to infinity, summation k is equal to 1 to n, divide this by this, separate the terms, divide individually. Numerator is sum of two terms, separating the terms. A minus b by c is a by c minus b by c, separating it. So I'll get k plus 1 into k plus 2 into k plus 3 divided by k plus 3 factorial. K plus 3 factorial could be written as k plus 3 into k plus 2 into k plus 1 into k factorial, okay, minus 1 by k plus 3 factorial. Hope you understand this. K plus 1 into k plus 2 into k plus 3 is going to cancel here, correct? That's equal to limit n tends to infinity, limit n tends to infinity, what we have? Summation of k is equal to 1 to n. What is left out is 1 by k factorial minus 1 by k plus 3 factorial, like this. Apply. Limit n tends to infinity, I'll apply last. First take the summation of this. Here k is varying from 1 to n, no? There are n terms, correct? Start putting k equal to different values, 1, 2, 3 till n. When you put k equal to 1, no, this will start with 4 factorial, because 1 plus 3 is 4. 4 factorial onwards it starts. 4 factorial onwards. That is limit n tends to infinity. Limit n tends to infinity. The first bracket will be 1 by 1 factorial plus 1 by 2 factorial, 1 by 3 factorial, etc. That is 1 by n factorial. 1 by n factorial minus. Put k equal to 1 for this. 1 plus 3, 4 factorial once it starts. It starts from 4 factorial. 1 by 4 factorial plus 1 by 5 factorial, 1 by 6 factorial, etc. Last term is 1 by k plus 1 by n plus 3 factorial. 1 by n plus 3 factorial. Like this we get. See, many of the terms are going to cancel here. Correct? Here 1 by 4 factorial is present in both the brackets, right? First three terms are present here, but it's not present here. 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial is not present there. So that will not cancel. 1 by 4 factorial onwards till 1 by n factorial cancels. This term will cancel with these terms up till 1 by n factorial. Here the first three terms will remain. Here the last three terms will remain. Correct? What are the last three terms actually? 1 by n plus 3 factorial. Previous to that, 1 by n plus 2 factorial. Previous to that, 1 by n plus 1 factorial. Previous to that is 1 by n factorial. That will cancel. So 1 by 4 factorial to 1 by n factorial terms will cancel. What will not cancel in the first bracket and second bracket, I should write. Okay. So that's equal to limit n tends to infinity. Limit n tends to infinity. What we have? The first three terms are left out. 1 by 1 plus 1 by 2 factorial is 2. 1 by 3 factorial is 6. Minus this much is left in the first bracket. In the second bracket, the last three terms left are 1 by n plus 1 factorial plus 1 by n plus 2 factorial plus 1 by n plus 3 factorial. Correct? As n tends to infinity, 1 by infinity becomes 0. All these terms are gone. 0. Correct? N tends to infinity. N plus 1 factorial is still large. Becomes quite big number. Infinity. 1 by infinity is 0. All these things becomes 0. 1 by infinity is 0. 1 by infinity, 1 by 0. So what is left is only this. And limit of a constant is constant. Only these three terms are left. 6 is common denominator. 6 plus 2 into 3. Correct? Here 6 into 1, 1 into 1. So what you get is 6 plus 3, 9 plus 1, 10. 10 by 6. That is equal to 5 by 3. Answer is 5 by 3. Option D. Hope I understood this. Important step is this. Writing q plus 6k square plus 11k plus 5 as k plus 1 into k plus 2 into k plus 3 minus 1. Because here is 6, here it's 5. Important observation. Solution is given here. Move on to the next one. 10th one. Alpha, beta, gamma, real numbers. Limit x tends to 0 of this expression is given to be equal to 3. Find beta plus gamma minus alpha. Question on series expansion. Whenever there are unknown things, no, and it contains sine, e power x, all those things, normally we apply series expansion. Can you try this? Already we've done many questions of this type in several shifts of various PYQs. First we'll find the value of gamma here. Okay. As x is approaching to 0, denominator is becoming 0, no? So we insist the condition that numerator should be 0, so that limit is finite. As x approaches to 0, as x is approaching to 0, denominator is becoming 0, right? 2 into 0, 0, sine 0, 0, beta into 0, 0. Denominator is approaching to 0. So I can tell numerator also should tend to 0. As x approaches to 0, denominator is becoming 0. So numerator also should tend to 0. So that it takes 0 by 0 form. If it takes 0 by 0 form, I can apply L'Hopital's rule and find the limiting value. Otherwise, what happens? If denominator is becoming 0 and numerator is non-zero, then non-zero by 0 means it becomes limit does not exist. Correct? But right hand side is given to be equal to 3. So limit should exist finitely. For limit is already existing finitely because the right hand side I can see 3. So limit of this function exists finitely. Because denominator is approaching 0, we insist the condition that numerator should tend to 0. So that if it is 0 by 0 form, one can apply L'Hopital's rule or L'Hopital's rule and apply the limit and get the answer as 3. Understood? If on the contrary, if denominator is already becoming 0 and if numerator is non-zero, non-zero by 0 can't be equal to 3. It becomes a contradiction to the statement. So I use the condition that numerator is approaching to 0. Put x equal to 0 on this. 0 square into sine of 0. This part is 0, no? 0 square into sine 0. 0 square into sine 0 plus gamma minus 1 into e power x square, e power 0. That should be equal to 3. Correct? That should be equal to 0. Sorry. Numerator is becoming 0. Correct? Numerator is becoming 0. Numerator is becoming 0. I'm equating to 0. So what do you get? 0 square into sine 0, 0. E power 0 is 1. 1 into gamma minus 1. So gamma minus 1 is equal to 0. That gives gamma is equal to 1. I got the value of gamma. Gamma equal to 1 I got. That gamma equal to 1 you can substitute there. So given expression gets simplified. Putting gamma equal to 1 in the given expression. Put gamma equal to 1 in the given expression. Put gamma equal to 1 in the given expression. What do you get? Limit x tends to 0. Limit x tends to 0. Putting gamma equal to 1. 1 minus 1, 0. No? 0 into something is 0 there. So that part is 0. I won't write that. So what I'll write is only x square into sine alpha x. X square into sine alpha x. Putting gamma equal to 1, this will become 0. Hope you understand. I won't write this part. So x square into sine alpha x divided by sine 2x minus beta x. Sine 2x minus beta x is given to be equal to 3. Putting gamma equal to 1 in the given expression or in the given equation I can tell. In the given equation. Okay. In the given equation. Now, in the numerator, I'll multiply and divide by alpha x because sine of an angle by same angle is 1 as x approaches to 0, correct? As x approaches to 0, I'm using that concept. Limit x tends to 0, what we have? X square into sine alpha x divided by alpha x multiplied by alpha x divided by sine 2x minus beta x is equal to 3. Correct? This will approach to 1. Sine of an angle by same angle is 1. Multiply and divide by alpha x in the numerator. So what is rounded off that bracket is 1. So alpha x cube I get in the numerator. So I'll write this as limit x tends to 0. Numerator is what? Alpha into x cube. Alpha x into x square. Alpha x cube. Limit x tends to 0. Alpha x cube divided by sine 2x minus beta x. Because the numerator contains only one term and denominator there is two terms and that too sine function is there, I'll take reciprocal on both sides. We'll take reciprocal on both sides here. That is limit x tends to 0. Taking reciprocal of this, sine 2x minus beta x divided by alpha into x cube is equal to 1 by 3. Limit will remains the same, only taking the reciprocal of the function and the constant on the right hand side. So now write the series expansion for sine 2x up till x cube. Okay, because denominator is containing x cube. No, write the infinite series expansion for sine 2x. We know sine x series expansion as x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial etc. up to infinity. All those things not required. Only write the terms up till x cube because denominator is x cube. Correct? The rest other terms will become 0. That's why I'm not writing all the terms. So I'll just indicate the other terms. Limit x tends to 0. Sine 2x will be what? Sine 2x is 2x minus 2x the whole cube divided by 3 factorial plus 2x to the power 5 divided by 5 factorial etc. up to infinity. Correct? That's not required actually. Only the first two terms were enough. Still I've written it. Minus beta x divided by alpha into x cube. Correct? Is equal to 1 by 3. So you collect the terms with x. You collect the terms with x cube. Separate the terms also. So if you take the terms with x, no, x common here between this term and this term, x common. So 2 minus beta I'll get. Correct? If you separate the terms also simultaneously, then separate the terms. Limit x tends to 0. Collecting the terms with x into 2 minus beta x into 2 minus beta divided by alpha into x cube. Correct? Then what is left out? Minus 2 cube is minus 8. 3 factorial is 6. 8 by 6, that is 4 by 3. Minus 4 by 3, x cube will cancel. Correct? Minus 4 by 3, x cube will cancel, divided by alpha. Next term will be plus, here 2 power 5 is 32. 5 factorial is 120. All those things not required. Just I'll show you. 32 divided by 120. X power 5 by x cube, that is divided by alpha into x square. Other terms I am not writing. Close the bracket, equal to 1 by 3. From here onwards, all the terms will become 0. When you apply limit, x tends to 0. From here onwards, numerator contains x. So 0 into that, all the terms will become 0. All the terms. Even after writing the higher powers of x and dividing by alpha x cube, all the terms will become 0. Correct? When you apply limit, I am telling, x tends to 0. And here, this is a constant term. This became 0 after applying limit, and this is a constant. Limit of a constant is constant. But here you see 1x will cancel and x square remains in denominator. In the denominator, x square remains. That means the denominator is becoming 0. Limit does not exist. So limit is already given to be a finite number, 1 by 3. For limit to exist, as denominator is becoming 0, numerator should tend to 0. So we insist the condition that 2 minus beta should be 0. Correct? For limit to exist, 2 minus beta should be equal to 0. So we get beta is equal to 2. Beta is equal to 2. And the constant term here, that is the limiting value actually. This should be equal to 1 by 3. Correct? Minus 4 divided by 3 alpha, that should be equal to 1 by 3. Correct? So here 3 cancels. Cross multiply, we get alpha equal to minus 4. Alpha equal to minus 4 we get. Minus 4 by 3 alpha. This 3 comes to denominator. That's equal to 1 by 3. 3 cancels. Alpha equal to minus 4. Every constant we got. Therefore, finally we want to find beta plus gamma minus alpha. Beta plus gamma minus alpha. Beta how much? 2. Gamma how much? 1. Gamma we got here. Gamma is 1. Gamma is 1. Alpha is minus 4. 2 plus 1, 3. 3 plus 4, 7. So answer is option C. Hope you understood this. I took the reciprocal because the x cube in the denominator means it becomes easy for us. Writing series expansion for sine up till x cube. Okay. This is not required. Just as shown it. All the other terms will become 0. All higher powers of x will become 0. Even after dividing by x cube and applying limit. Already we done this type of question many times. So answer is 7 we got. 7 is answer. Next one. Even this question is based on the series expansion. Want to find a plus b. Limit x tends to 0. Denominator is becoming 0. Numerator also should tend to 0. Can use that kind of concept, or I can use directly series expansion. Applying series expansion directly for cos 2x and cos 4x. Cos 2x and cos 4x. What is series expansion for cos 2x? 1 minus 2x the whole square divided by 2 factorial. Correct? Plus 2x to the power 4 divided by 4 factorial minus dot dot dot. Correct? Writing series expansion for cos. Cos x is 1 minus x square by 2 factorial plus x power 4 by 4 factorial etc. up to infinity. I am writing only up till x power 4 because denominator contains x power 4. All higher powers of x will become 0. I mean apply the limit. Correct? Plus a into cos 4x. Cos 4x is 1 minus 4x the whole square divided by 2 factorial plus 4x to the power 4 divided by 4 factorial etc. up to infinity minus b divided by x power 4 divided by x power 4. This is given to be equal to finite. Correct? Collect the terms which are containing x power 4. Collect the terms with x square and collect the constant term. This is a finite number. Is finite the given in the question. Collect the constant terms. Which are constant terms here? 1 plus a into 1 a minus b, and separate the terms also. So I can write this as limit x tends to 0, limit x tends to 0, what we have? 1 plus a minus b divided by x power 4. 1 plus a minus b divided by x power 4. Correct? Here minus 2x square, that is minus 4x square by 2 factorial. Correct? That will be, I'll write plus, here inside the bracket I'll write the terms with x square. I'm writing 4 by 2, that is 2 minus 2 in fact. Correct? 2 square, 4 by 2. Here 4 square 16, 16 by 2 is 8, 2 factorial is 2, 16 by 2 is 8. So minus 8a, correct, into x square terms I wrote, x square by x power 4, that will become x square. Correct? I'm separating. Next I'm writing the coefficient of x power 4. Coefficient of x power 4 is 2 power 4, 16. 16 by 24. 16 by 24, that is 2 by 3. Correct? 2 by 3. 2 power 4, 16. 4 factorial is 24. 16 by 24 is 2 by 3. Here what we get? 4 power 4 by 4 factorial. 4 power 4 is 256 and 4 factorial is 24. Correct? We can cancel with 8 table. 8 3s are 24. 1 carry, 8 2s are, this is 32 by 3. 8 3s are 8 into 32. Correct? No? So 32 by 3 I'm getting. 32 by 3 b. 32 by 3 into b, into a, sorry, into a. by 3 into a. Correct? And that is the coefficient of x power 4. X power 4 by x power 4 will become 1. And all other terms I am not writing, which will contain x terms. When I apply limit, it becomes 0. Correct? Like this I am getting after separating the terms. And this is a constant term. Limiting value is going to be this. Okay? Because when you apply limit, all these terms become 0. Will contain higher power of x. When you divide by x power 4, it will contain x in the numerator, x or x square. Such terms will be present in the numerator. All those terms will become 0. So we insist the condition that because the denominator is becoming 0, numerator should become 0. So for limit to exist finitely, we have 1 plus a minus b should be 0. And also this should become 0. Because the denominator is becoming 0, numerator should become 0. Minus 2 minus 8a equal to 0. That is 2 plus 8a equal to 0. Or 8a equal to minus 2, a equal to minus 1 by 4. 8a is equal to minus 2, we get a equal to minus 1 by 4. Put the value of a as minus 1 by 4 here. We get 1 minus 1 by 4 equal to b, that is b equal to 3 by 4. We got the values of a and b. What we need to find is a plus b. Therefore, a plus b is equal to a is minus 1 by 4, b is 3 by 4. 3 by 4 minus 1 by 4. 2 by 4 is half. Answer is half. Option A. Next one. Limit x tends to 0. Tan x by x to the power 1 by x square is given as p. Find 96 log p equal to how much? As x approaches to 0, tan x by x is approaching 1, right? As x approaches to 0, we know that tan x by x will approach to 1. And the power is 1 by x square. 1 by x square is approaching to infinity. As x approaches to 0, the base is approaching 1 and the power is approaching infinity. The typical JEE level question, this is 1 to the power infinity form. 1 to the power infinity, what is the formula? E power limit base into power minus 1. So what we have? E power limit x tends to 0. The power, you write 1 by x square into tan x by x minus 1. Correct? E power limit g of x into f of x minus 1. Write the power first into base minus 1. Simplify this. We can use series expansion here to evaluate this limit. 1 by x square is there. Denominator take LCM x. So I'll get tan x minus x e power limit x tends to 0. What we get is tan x minus x divided by x cube. What is the series expansion for tan x? Tan x series expansion is right up till x cube terms. Then we'll get the answer because denominator contains x cube, no, in the power. So this is equal to e power limit x tends to 0. Tan x series expansion is x plus x cube divided by 3 plus 2 by 15 x power 5 etc. up to infinity, correct, minus x divided by x cube. X will cancel, plus x minus x. So what we get is e power limit x tends to 0. We can separate the terms and write x cube by 3 by x cube. X cube cancels, 1 by 3 plus 2 by 15. X power 5 by x cube is x square, etc. goes on. From here onwards, all the terms will become 0 because it contains x in the numerator. From all these terms will become 0. So we get the answer as e power 1 by 3. This part is becoming 0. E power 1 by 3. That is the value of p. That's the value of p here. You have to find 96 log p. Take log on both sides. So log of e power 1 by 3 is equal to log p. Correct? The power comes down. So this becomes 1 by 3 into log e is equal to log p. And you know log e is 1. Therefore I get log p is equal to 1 by 3. Log p is 1 by 3. Want to find 96 log p. 96 log p is equal to 96 into 1 by 3. 96 into 1 by 3 is how much? 32, correct? 32 is the answer. Numerical type question, simple one. Answer is 32. Next one. Limit x tends to 1 plus. Again, it applies series expansion because you can see cos and sine here, correct? And x tends to 1 plus. And x minus 1 will tend to 0 plus, correct? First you note that as x is approaching 1 plus, as x tends to 1 plus, x minus 1 is the angle present there. X minus 1 will approach to 0 plus and 1 minus x will tend to 0 minus, correct? X minus 1, you can put it as some variable t here. Put x minus 1 equal to t. Okay. Put x minus 1 equal to t so that t will tend to 0 plus. As x tends to 1 plus, the t will tend to 0 plus. And 1 minus x will be minus t. Okay. So I'll be using this. So instead of writing limit x tends to 1 plus, I'll write limit t tends to 0 plus. Because you can see x minus 1 everywhere and here 1 minus x. 1 minus x is minus of x minus 1, correct? So I'll write in terms of t. As x approaches 1 plus, t approaches to 0 plus. X minus 1 is t. T into 6 plus lambda into cos t, correct? Close the bracket. Plus mu into sine of minus t. Sine of minus t is minus sine t divided by here t cube. That is equal to what? Limit t tends to 0 plus. What we get? This minus we bring outside and write the series expansion for cos and sine. Okay. Up till t cube. So this will be 6t plus lambda t into cos t, write the series expansion. Cos t is what? 1 minus t square by 2 factor, enough. Rest are not required because already if you multiply I get t cube, correct? Plus into minus, sine of minus t is minus sine t, minus comes out, minus mu into, what is sine t? Sine t is t minus t cube divided by 3 factorial etc. up to infinity, correct? Divided by t cube, Simplify this. Up till t cube is enough. Rest terms are not required. Collect the terms with t cube. Collect the terms with the t. First we'll collect the coefficient of t here. Constant term is not there anyway here. Correct? Limit t tends to 0 plus. What we have? T is common here. T if you take out, I'll get 6 plus lambda into 1. Lambda here minus mu. Correct? Divided by T cube. Next to collect the terms with T cube. Collecting terms with T cube. T cube if you take out, what remains? Here there is no T cube. Here there is T cube. Minus lambda by 2. 2 factorial is 2. Minus into minus plus mu by 3 factorial is 6. Correct? Divided by T cube. Rest terms I won't write. Higher powers. T power 5 etc. will be there. All those things, when you divide T power 5 by T cube, it becomes a T square. When you apply limit, it becomes 0. Rest terms, I'll write put dot like this. This is given to be equal to minus 1. No? It's given to be equal to minus 1. Separate the terms. Denominator, here the numerator, denominator 1t will cancel. Denominator becomes a t square and denominator is becoming 0. Because t tends to 0 plus, denominator is becoming 0. So we insist the condition that numerator should become 0. For limit to be finite, we have 6 plus lambda minus mu should be equal to 0. And t cube is going to cancel, and when you apply limit of this expression is going to be this constant value, limiting value is this only, that should be equal to minus 1. So minus lambda by 2 plus mu divided by 6 is equal to minus 1. Solve the two equations. This you can multiply by 6 and write, no? From this, if you multiply by 6, I get minus 3 lambda plus mu is equal to minus 6. Add the two equations. This is lambda minus mu is equal to minus 6. Equation 1, equation 2. Solve the two equations. Add the two equations. What do we get? Mu minus mu is cancelling. Adding equations 1 and 2, minus 3 lambda plus lambda, we get minus 2 lambda, correct, is equal to minus 6 minus 12. So we get lambda equal to 6. Lambda equal to 6. Lambda equal to 6 you substitute there. Mu is lambda plus 6, correct. From this first equation, mu is lambda plus 6. Mu is equal to lambda plus 6. Lambda we got 6. 6 plus 6 is 12. Therefore, we got lambda and mu. Therefore, lambda plus mu is going to be equal to 18. Answer is option B. Therefore, lambda plus mu is equal to lambda 6, mu is 12, 6 plus 12, 18 is the answer. Option. Solution is given here. Move on to the next one. Let f be a differentiable function on R such that f of 2 is 1, f dash of 2 is 4, limit x tends to 0, f of 2 plus x power 3 by x equal to e power alpha. Find the number of times the curve y equal to 4x cube minus 4x square minus 4 into alpha minus 7 into x minus alpha meets x-axis. First find the value of alpha. This takes 1 to the power infinity form. See, as x approaches to 0, 2 plus 0 is 2, f of 2 is given to be equal to 1 and the power is becoming 3 by 0 which is infinity, takes 1 to the power infinity form, correct. As x approaches to 0, correct, f of 2 plus x approaches to f of 2 is given to be equal to 1, correct. So base is becoming 1 and the power is becoming infinity. 3 by x will tend to infinity. So takes 1 to the power infinity form. Apply the formula e power limit g of x into f of x minus 1. Therefore, e power alpha is equal to e power limit x tends to 0. The power you write first into base minus 1. F of 2 plus x minus 1. That's equal to, bases are same, no? So equate the powers. Because of equality, I can equate the powers because bases are same. So I'll get alpha is equal to limit x tends to 0. We can write this as 3 you can take outside. No, 3 is a constant. 3 you can keep outside. What we have is f of 2 plus x minus 1 divided by x. When I apply limit, no, x equal to 0. 2 plus 0 is 2. F of 2 is 1. Correct, f of 2 is 1, 1 minus 1 by 0. As x approaches to 0, this takes 0 by 0 form. Apply L'Hopital's rule. Differentiate numerator and denominator separately. What do you get? Limit x tends to 0. Derivative of f of 2 plus x. F dash of 2 plus x into derivative of 2 plus x 1. Derivative of 1 0. Derivative of x is 1. Apply limit now. This becomes 3 into f dash of 2 plus 0 2. That is 3 into f dash of 2 is given to be equal to 4. So 3 into 4 is equal to 12. Correct? Using these conditions. F of 2 is 1 and f dash of 2 equal to 4. Applying the conditions we get this. So we got the value of alpha. Alpha is equal to 12. Now substitute this value of alpha equal to 12 in this and find the number of times it meets the x-axis. Y is equal to what we get? 4x cube minus 4x square minus 4 times alpha we got 12. 12 minus 7 is 5x minus alpha is 12. Put alpha equal to 12 as we got here. Okay. So this is equal to what we get? 4x cube minus 4x square minus 20x minus 12. It meets the x-axis. Curve is meeting the x-axis means what? At that point y coordinate should be equal to 0. Some curve is there. Some curve is meeting the x-axis means what? At that point y coordinate equal to 0. Correct? So at that point y equal to 0 means x-axis implies y equal to 0. Put y equal to 0. Y equal to 0. So 4 is common here. 4 you take out. X cube minus x square minus 5x minus 3 equal to 0. 4 can't be 0. So terms inside the bracket should be equal to 0. X cube minus x square minus 5x minus 3 equal to 0. As 4 can't be equal to 0, the terms inside the bracket should be 0. A into B 0 means either A equal to 0 or B equal to 0. Correct? We know that. So to solve this cubic equation, the first root should be got by the method of inspection. Correct? By inspection method, you can see x equal to minus 1 satisfies. Easily I can tell. Put x equal to minus 1. Put x equal to minus 1. It satisfies, no? Minus 1 cube minus 1 minus 1 square 1 minus 5 into minus 1 plus 5 minus 3 minus 1 minus 1 minus 3 minus 5 plus 5 0. 0 equal to 0 satisfies. So x equal to minus 1 is the root of that. So x plus 1 should be factor. If x equal to alpha is a root, x minus alpha is a factor by remainder and factor theorem. So x equal to alpha is a root means x minus alpha should be the factor of that. So because x equal to minus 1 satisfies this equation, I can divide by x plus 1, I'll get other root. Okay, divide this polynomial by x plus 1. Divide this polynomial by x plus 1 because x equal to minus 1 is a root. I am dividing by x plus 1. X equal to alpha is a root means x minus alpha should be the factor. Understood? So I am dividing by x minus 1 which is x plus 1. X multiplied by x square we get x cube. 1 into x square. Subtract minus cancels. Minus 2x square minus 5x minus 3. X are to multiply by minus 2x. So I get minus 2x square plus 2x. Okay, and when you subtract this, no, minus 2x square plus 2x square cancels. Minus 5x, minus 2x, sorry, here it's minus 2x. So when you change the sign, I'll get minus 3x. Minus 3x minus 3. X are to multiply by minus 3. So that remainder will be 0 here. When you subtract, no, plus remainder becomes 0. So x square minus 2x minus 3 is the other factor. So x square minus 2x minus 3 equal to 0. If you do, I'll get x minus 3 into x plus 1 equal to 0. Correct? Factorizing. Minus 3 plus 1 is minus 2. So I'll get a into b 0 means what? Either a equal to 0 or b equal to 0. X equal to 3 or x equal to minus 1. So minus 1 is a repeated root. Already we got x equal to minus 1 here. Correct? X equal to minus 1 is a repeated root. So the number of times the curve is meeting the x-axis is at 2 points. One is at x equal to minus 1, another at x equal to 3. So the roots of this equation are minus 1 and 3. Minus 1 is a repeated root. Number of times it meets the x-axis is 2. Option C is answer. 2 points. Minus 1 and 3. On to the next one. Question number 15. There are statement 1 and statement 2 type of question is given here. Question asked on 8th of April 2nd shift 2025. Limit x tends to 0. Tan inverse x plus log to the base root 1 plus x by 1 minus x minus 2x divided by x power 5 is given to be equal to 2 by 5. Verify statement 1 is true or false. Then statement 2 is given as limit x tends to 1, x power 2 by 1 minus x equal to 1 by e square. Statement 2 I shall do first, that's easy actually. Statement 2 is limit x tends to 1, it takes 1 to the power infinity form, x to the power 2 by 1 minus x, correct? The base is approaching 1, correct? As x approaches 1, as x approaches to 1, the base is approaching 1, numerator, I mean base, I can write not base, not numerator, base is approaching 1, base is x, correct? Base is x, base is approaching 1 and the power is approaching infinity. Base is x, x is approaching 1 and the power is what? 2 by 1 minus x, that is 2 by 0, approaches to infinity, correct? So I can use that formula, e power limit x tends to 1, g of x into f of x minus 1, 2 by 1 minus x, e power limit g of x into f of x minus 1. So what do you get? E power limit x tends to 1, what we have 1 minus x minus 1 will cancel, correct? So I can write minus 2 into 1 minus x by 1 minus x. So that 1 minus x will cancel. I get e power minus 2, which is 1 by e square. So statement 2 is correct. Statement 2 is correct. So it can't be fourth option. It can't be the second option, correct? Because the given statement 2 is false in second and fourth option. Either it is option A or option C. Now to evaluate the limit of this given in statement 1, I should use series expansion. Okay, tan inverse x, you write the series expansion and log of root 1 plus x by 1 minus x. First to simplify that using the property of log, I shall do it in the next page, becomes little lengthy there, correct? Limit x tends to 0, limit x tends to 0, tan inverse x, limit x tends to 0, what is given? Tan inverse x plus log of root 1 plus x by 1 minus x, correct? Then what is given? Log of root 1 plus x by 1 minus x minus 2x by x power 5. If we evaluate that, I should get the answer as 2 by 5. If I get, it's correct, otherwise it's wrong. Statement 1, correct? Minus 2x divided by x power 5 minus 2x divided by x power 5. And you can write log of root 1 plus x by 1 minus x as, root means to the power half, right? This is what? Log of, what we have? 1 plus x divided by 1 minus x to the power half. The power half comes down, half into log of 1 plus x divided by 1 minus x. That is half into log a by b. Log a by this, log a minus log b, log 1 plus x minus of log 1 minus x, correct? The power comes down, half comes down, log a by b, log a minus log b. So that is equal to limit x tends to 0, tan inverse x plus half log a by b, I wrote log a minus log b. First is log m power n, n log m, then use the property again, log a by b, log a minus log b, half into log of 1 plus x minus log of 1 minus x, correct? Close the bracket, minus 2x divided by x power 5. I should write the series expansion up till x power 5. Because denominator contains x power 5, write the numerator series expansion for tan inverse x, log 1 plus x and log 1 minus x. Okay, so tan inverse x series expansion is what? X minus x cube by 3 plus x power 5 by 5. Correct? Others not required, only the first 3 terms enough. Up till x power 5 is enough. Here it is tan inverse x, I am writing x minus x cube divided by 3 plus x power 5 divided by 5, etc. goes on. Enough. Next, half into log 1 plus x. Log 1 plus x is x minus x square by 2 plus x cube divided by 3 minus x power 4 by 4 plus x power 5 by 5. Series expansion for log 1 plus x. Close the bracket. And one more is there, half of this much. And here log 1 minus x is minus of, that minus into minus will become plus. What is left is x plus x square by 2 plus x cube divided by 3 plus x power 4 by 4 plus x power 5 by 5, etc. Sorry. X power 4 by 4 plus x power 5 by 5, etc. up to infinity goes on. Close this bracket, close another bracket, minus 2x is there, minus 2x divided by x power 5. Whole thing is divided by x power 5. What we get? Here x plus x is 2x, no? X plus x, 2x. 2x into half will be x. That x and this x will add up. 2x. 2x minus 2x will become 0 finally. Understood? X plus x is 2x. This x and this x will add up to 2x. 2x into half x. X plus x, 2x. 2x minus 2x will cancel. So this x, x gone. Here minus x cube by 3 is there, correct? And what about this minus x square by 2 plus x square will cancel. These two will add up to 0. These two within this bracket will add up to 0. X cube by 3 plus x cube by 3 is 2x cube by 3. 2x cube by 3 into half is x cube by 3. X cube by 3 minus x cube by 3 will cancel, 0. And x power 4 will cancel. See here minus x power 4 by 4 plus x power 4 by 4 will cancel. Correct? These two will cancel. Will add up to 0. X power 5 by 5 plus x power 5 by 5. That is 2x power 5 by 5. 2x power 5 by 5 into half is x power 5 by 5. That x power 5 by 5, this x power 5 by 5 becomes 2x power 5 by 5. Correct? Limit x tends to 0. What I'm getting is 2 by 5 x power 5 plus whatever I didn't write. No, all the terms will contain x, and when you divide by this by x power 5, whole thing is divided by x power 5 is there. So I'm getting, separate the terms, 2 by 5 x power 5 by x power 5. X power 5 cancels. We get 2 by 5 plus, when you apply limit for other terms, no, other terms will contain higher powers of x, x power 7 and all. X power 7 by x power 5 become x square, and whatever terms I'm not writing, all the terms will become 0 because the limit x tends to 0 is there. So answer is 2 by 5. Statement 1 is also correct. Both the statement 1 and 2 are true. Both statement 1 and statement 2 are true. Option C is the answer. Hope you understand. Writing series expansion for tan inverse x, writing series expansion for log 1 plus x, writing series expansion for log 1 minus x. Log 1 minus x is minus of x plus x square by 2 plus x cube by 3 plus x power 4 by 4 plus x power 5 by 5, etc. Minus of. So minus into minus is plus. Okay. Solution is given. Statement 2 is also true. Statement 1 is true. Option C is the answer. Detailed solution is given to you here. Next one, question number 16. Alpha suffix t and beta suffix t are the roots of the quadratic equation. Similar type of question was asked in JEE Advanced. During that time it was called as IIT JEE exam because it was appeared in 2012. Okay, that time it was not called as JEE Advanced, it was called as IIT JEE. It's an equivalent exam to JEE Advanced only. So similar type of question was asked there. Okay. So if you're preparing for JEE Main, you can also study the PYQs of JEE Advanced. Many times questions have been asked from JEE Advanced PYQs in JEE Main exam also. Okay, in integration, in differentiation, and many other topics in 3D geometry, vector algebra, many times questions have been asked. So if you study the PYQs of JEE Advanced also, it's better. So another kind of preparation. Even that also we shall do. Okay, after completing all the JEE Main PYQs, we'll go to JEE Advanced, and also we'll be doing the different books like Singh, R.D. Sharma and Arihant, different important questions, top questions of each and every chapter we shall work out. which is not here, but also we shall work out, because many times questions will be asked from some of the books, standard books like R.D. Sharma, Singhage and Arihant. Okay. So which will take such questions also. There will be a lot of revision also. Those who are not knowing about this, my YouTube channel, I am discussing limits chapter 2019, 2020, 2021, 2022, 2023, 2024. We have completed all the PYQs of limits. I am doing 2025 now. And also I've done the synopsis part. After completing this, I'll go to all the PYQs of 2025 will complete. All the different topics will complete. Vector algebra, 3D geometry, all the topics will complete one stretch and cover the PYQs of different years going back till 2019. Okay, and also there will be revision classes and also NCERT syllabus also I'll be doing. I'm a new YouTuber actually, started from last 1.5 months, nearly 45 to 50 days back we started. We've done a few videos, many more videos I'll be uploading. Okay, please subscribe to my YouTube channel, tell all your friends also, students as well as teachers also, this is helpful, good videos I'll be uploading so that it is useful for each and everyone. Okay, please do subscribe to my YouTube channel, Abhiram's Maths Marathon it's called as. Okay, 16th question asked on 7th of April, second shift 2025. Alpha suffix t and beta suffix t are the roots of this equation. Limit t tends to -1 plus alpha t is given as A. Limit t tends to -1 plus beta t is given as B. Want to find 7 times A plus B the whole square. So alpha t and beta t are the roots of this equation. What is the equation given there? T plus 2 to the power 1 by 7 minus 1 x square plus t plus 2 to the power 1 by 6 minus 1 into x plus t plus 2 to the power 1 by 21 minus 1 equal to 0. What are the roots of this equation? Alpha t and beta t are the roots. Alpha t and beta t are the roots of this equation. Want to find A plus B the whole square into 72. What is A? Limit t tends to -1 plus of alpha. We shall find out the sum of the roots. Okay. Limit t tends to -1 plus of beta t is B. So sum of the roots. Sum of the roots, alpha t plus beta t, sum of the roots, that is alpha suffix t plus beta suffix t will start. Sum of the roots we know, minus coefficient of x by coefficient of x square, minus b by we call, minus coefficient of x by coefficient of x square, correct? Minus coefficient of x divided by coefficient of x square. What we have, that is equal to minus of coefficient of x is what we have, t plus 2 to the power 1 by 6 minus 1 divided by coefficient of x square is t plus 2 to the power 1 by 7, t plus 2 to the power 1 by 7 minus 1. Take limit on both sides. Take limit on both sides. And this takes 0 by 0 form. If I apply limit here, limit t tends to -1 plus of alpha suffix t plus beta suffix t is equal to limit t tends to -1 plus of this expression minus of t plus 2 to the power 1 by 6 minus 1 divided by t plus 2 to the power 1 by 7 minus 1. If I apply limit directly, t equal to -1, -1 plus 2 is 1, 1 power 1 by 6 1, 1 minus 1 0, put t equal to -1, -1 plus 2 1, 1 power 1 by 7 is 1, 1 minus 1 0, take 0 by 0 form, can apply L'Hopital's rule, and limit of sum is sum of the limits. I can apply limit for individual. So limit t tends to -1 plus of alpha t plus limit t tends to -1 plus of beta t. Limit of sum is sum of the limits, correct? Limit of alpha t plus beta t is limit of alpha t plus limit of beta t. That's equal to apply L'Hopital's rule for this. L'Hopital's rule for this. What do you get? limit t tends to minus 1 plus, limit t tends to minus 1 plus, applying differentiation for numerator and denominator, minus is there already, derivative of t plus t power 1 by 6 is 1 by 6 into t plus t to the power 1 by 6 minus 1, that is minus 5 by 6, derivative of 1 is 0 here, divided by denominator 1 by 7 into t plus 2 to the power 1 by 7 minus 1, that is minus 6 by 7 minus 0, correct? If I apply limit here, t equal to minus 1, minus 1 plus 2 is 1, 1 to the power number is 1 only there. So here also minus 1 plus 2 is 1, 1 to the power minus 6 by 7 is 1 itself. So what we get, limiting values minus 1 by 6 by 1 by 7, which is equal to minus 7 by 6. And limit t tends to minus 1 plus of alpha t is given to be equal to e according to the question. So this is a, correct, plus limit t tends to minus 1 plus of beta t, that is given to be equal to b. Substitute, I'm using this and this. This is equal to a and this is equal to b. A plus b is equal to minus 7 by 6. So what is a plus b the whole square? A plus b the whole square is 49 divided by 36. Want to find 72 into a plus b the whole square, correct? 72 into a plus b the whole square, numerical type question. 72 into a plus b the whole square, we got 49 divided by 36. 36 ones are 36 twos are 2 into 49, which is 98. Simple question, mixed with quadratic equation. Limit concept is mixed with quadratic equation. Sum of the roots. Product of the roots is not required here. If you want, you can find out. In JEE advanced question, no, I told 2012 IIT JEE exam, the question was asked similar type. They asked to find the individual values of this. You can find the individual values of this. You can find what is A and B also. By using the product of the roots and sum of the roots, I can find the individual values. The product of the roots is what? C by A, constant term divided by coefficient of x square. If you find the product of the roots, A into B, I can find out. A into B will be constant term by coefficient of x square, and you can apply the L'Hopital's rule, 1 by 21 by 1 by 7. 1 by 21 after applying limit, I'm telling 1 by 21 by 1 by 7. That is 1 by 3 I'll get, A into B. A plus B we got minus 7 by 6. AB we got 1 by 3, and you can find A and B. You can find A minus B the whole square, or you can put B equal to 1 by 3A in this and solve the quadratic equation. You can get the individual values of A and B. Okay, similar type of question was asked. And we completed this question. Last one we have, I think, answer was 98 for this. The last question of 2025 limits we have. Limit x tends to 0 plus tan of 5x power 1 by 3 log of 1 plus 3x square by tan inverse of 3 root x the whole square into e power 5x power 4 by 3 minus 1 equal to how much? So here various theorems I can apply. We know these familiar results. Limit x tends to 0, log 1 plus x by x is 1. Correct? Limit x tends to 0, log of 1 plus something divided by same thing is equal to 1. We know this. And we know limit x tends to 0, e power x minus 1 by x is 1. I'll be using all these theorems. And also I can do it by shortcut method also. One stretch I can get the answer. I'll do that also. Limit x tends to 0, tan inverse x by x is 1. Tan inverse x divided by x is 1. Okay. And one more is limit x tends to 0, tan x by x is 1. All these four are applicable here. 4 theorems. Limit x tends to 0, tan x by x is 1. Tan of an angle by same angle is 1. Limit x tends to 0, tan inverse x by x is 1. Limit x tends to 0, e power x minus 1 by x 1. Limit x tends to 0, log 1 plus x by x 1. All I'll apply. Also I'll do it by shortcut method. One stretch we can get the answer. Otherwise I'll try the answer first by shortcut. Here what matters is only the powers of x and the coefficients of x. See, look at the power of x here. Power of x 1 by 3, no, for tan function. What is the power of x for log function? 2. What sum of the powers of x how much? The numerator. In the numerator, sum of the powers is 2 plus 1 by 3, correct? Sum of the powers, numerator, the power of x here for tan function is 1 by 3, correct? For log function, the power of x is 2. What is 2 plus 1 by 3? 7 by 3. That is for numerator. This is for numerator. And for denominator, look at the powers of x. Power of x how much? Root x. Root x square how much? X. That means power of x 1. Plus, what is power of x here? 4 by 3. What is 1 plus 4 by 3? That is also 7 by 3. So, powers of x in the numerator and denominator same. Sum of the powers of the functions present there, sum of the powers of x of those functions present is same in the numerator and denominator. So, limiting value is nothing but the coefficient of x. What is coefficient of x here for tan function? Coefficient of x power 1 by 3 is 5. Correct? What is coefficient of x square here? 3. Denominator, what is coefficient of x after squaring? 3 square 9. Correct? Here, what is coefficient of x power 4 by 3? That is 5. Correct? 5 cancels. 3 by 9. 1 by 3 is the answer. One stretch we get the answer. So simple. Sum of the powers of x should be same in the numerator and denominator. Okay? Whenever these kind of functions are present. Tan inverse x, tan x, sin x or sin inverse x, log 1 plus x or e power x minus 1 by x, such kind of e power x minus 1, such kind of terms are there. Numerator see these functions. These functions should be present. Whenever these kind of functions are present, tan x, tan inverse x or e power x minus 1 or log 1 plus x or sin x or sin inverse x, in that case what I can do is directly you should see the condition first. The condition is that the sum of the powers of x in the numerator and sum of the powers of x in the denominator should be same. Then the limiting value is nothing but the coefficients of x. Take the products of the coefficients of x in the numerator and denominator. That's the answer. Understood? Coefficient of x power 1 by 3 is 5. Coefficient of x square is 3. Denominator, after squaring, what is the coefficient of x? That is 3 square, 9. Here coefficient of x power 4 by 3 is 5. If you are doing the actual method I'll do if you want. If you are not understanding this, the actual method is limit x tends to 0 plus, limit x tends to 0 plus, what we have? Tan of 5x power 1 by 3, correct? To divide by 5x power 1 by 3 and log of 1 plus 3x square is there, log of 1 plus 3x square divided by 3x square, because log of 1 plus something by same thing is 1. To balance it, I multiply by 5x power 1 by 3 into 3x square. Denominator is what? Tan inverse of 3 root x the whole square is there. Tan inverse of 3 root x is there. You divide by 3 root x the whole square and balance it by 3 root x the whole square. Next, what is it? E power 5x power 4 by 3 minus 1 divided by 5x power 4 by 3, so that the power and denominator is same. To balance it, what I should do? Put 3 root x the whole square into 5x power 4 by 3, like this. Here tan of an angle by same angle is 1. This will approach to 1. This will approach to 1. Log of 1 plus something by something is 1. Tan inverse of x by x 1. Correct? E power x minus 1 by x1. So what is rounded up? This is 1, this is 1, this is 1, 1 square 1, this is also 1. Everything became 1. So x power 1 by 3 into x square becomes x power 7 by 3. Root x square is x. X into x power 4 by 3. This will cancel. Correct? So what is left is 5 into 3, 15 by 3 into 5. 3 square is 3 square. 3 square is 9. 9 into 5. Correct? 5 ones are 5 threes are 3 ones are 3 threes are. Answer is 1 by 3. 3 square you should take. 3 square is 9. 9 into 5, 45. 15 by 45. 1 by 3 is the answer. Option C. Question asked on 7th of April 1st, 2025. Answer is 1 by 3. With this, we conclude this session. JEE Main 2025 limits topic. 17 questions were there altogether from January shift and April shift. And many more videos I'll be uploading in the coming days. Please subscribe to my channel and also give likes and also forward to your friends so that it is useful for them also. And tell about my Abhiram's Maths Marathon YouTube channel. Okay, with this I conclude. Thank you.